So good morning, everyone. Welcome to this 222nd edition of the Zak World of Façades conference series. My name is Ahmed. I'm part of the organizing team here at Zak. I'll quickly introduce the conference series for those who are attending for the first time around. I'll also introduce our event partners. We'll get straight into action. This event is a delayed event, as all of us know. It was originally in April, but because of the geopolitical scenario, we had to push it through a later date, which is today. But we've been able to recover 70-80% of our originally planned program, which is great. Challenging times for all of us, but I think it's good to see the industry out here, and hopefully we can rebuild from the start again. So we've been organizing this event since 2012. We've finished around 221 editions in 51 countries. Every place is different. The way facades are designed, engineered, installed are completely different. In Dubai, this is our 11th edition. So been here since 2015. So we have events from New Zealand up until Canada. And we go to some very unique places which we never thought probably a couple of years ago we would ever go. Albania was one of them. Uzbekistan, Georgia. These are places where there's a lot of new build construction happening. You've got then mainland Europe, which is mainly adaptive reuse. So different events have different themes, have different speakers. Today's speakers for today's event are also a wider reflection of this country and the region. So you have case studies from the UAE, from Saudi Arabia, from the nearby GCC countries. I've seen the presentations. They're very exciting. There's a lot of mention about artificial intelligence, at least from the architects in the design stage. We also have a panel discussion on AI. So hopefully you're going to enjoy today's storytelling. I'll quickly introduce our event partners. We've got 24 of them today. So AlBanna is from Japan, one of the global leaders in aluminum composite panels. They are in partnership with the Algoher group here in the UAE. So they are our first associate partner. Anometal is from China. They've got a pre-anodized solid aluminum panel which has a very nice coating and self-cleaning property. You'll hear from them later today. Axalta are global leaders in liquid coating and powder coating solutions. Dow, again, needs no introduction. This is Dow Sill, which is the sealant and the membrane weatherproofing division of Dow, which is a large American multinational. Ephesus are from Portugal. They are experts in weatherproofing solutions, breather membranes, vapor barriers, and other related products. Emirates Glass is one of the leading value-added glass processing company with a in-house coating division from a wider Glass LLC group. FPC is from Saudi Arabia. They have fabrics, so fabrics can be used on the facade as a cladding material or as a roofing material. They are a fast-growing Saudi company with global ambitions. Fujairah Rockwool factory is again from here, from Fujairah, so they've got stone-based insulation solutions and other pacifier protection products. Future is a value-added glass processor based here in Ras Al Khaimah. So they're launching a new dynamic glazing solution, which is, let's say, Glass 3.0, which is a next generation of dynamic glazing. They have the display outside. Guardian Glass, again, they need no introduction, but for those who don't know Guardian are global leaders in coated glass solution, an American company, part of the Koch Industries group. Gibao is from China, so they're one of the leading global silicon sealing solution providers. Janssen is from Switzerland. They are global leaders in steel, door, window, and curtain wall systems. OGC, Obekan Glass, is from Saudi Arabia. They are into coated glass solutions, one of the leading players in this region. Rock Annie are into fixing systems for the building envelope, rain screen, cladding, and other value-added products for the entire building envelope. CDAC is from Germany, one of the leaders in complex glass solutions, known for their jumbo glass, curved glass, and other solutions. They have a big bulletproof glass sample kept outside, which you cannot miss. Seele is one of the is a global contractor doing complex stuff from Germany. They are known for their Apple stores and other iconic projects which involves complexity. You'll be hearing from them later today. Shibo is from China. So Shibo have steel profiles for complex shapes and jumbo spans and all your mega projects. Siderice is from the UK. They've got pacifier protection products for rear ventilated cladding and curtain walls. Shishakam is another leading global manufacturer of coated glass. They are from Turkey with coaters in many different countries. Sudal is from Belgium. So they've got sealing and bonding solutions, pacifier protection products, and other value-added products for the door, window, and curtain wall segment. Studio Veneto are from Russia. So they've got a very interesting titanium cladding solution. Specialty product only for special projects. Check their booth out to see what finishes you can get in titanium cladding. Viva is from India, so they're one of the leaders in metal composite solutions, composite panels, solid aluminum cladding, and other non-combustible fire-rated cladding products. Walnova is from China. They've got a lot of value-added products like mashrabia, solid aluminum, perforated mesh, and any products which are a feature element for the building envelope. WHTV is also another Chinese company, so they've got jumbo glasses and curved glass specialty. So they are one of the jumbo glass processors out of China. So these are our partners for today's event. All of them have a tabletop booth outside. We have 2 networking breaks and we have a lunch break, so you can meet them throughout the course of the day. Our next event is in a couple of weeks in my hometown of Chennai, which is back in India. Maybe in the wider region, our next event is in Cairo, in Egypt, which is end of September. And of course, today's event is recorded. For those presentations which we have permission to share with you will be on our YouTube page. You can scan the QR code to follow our YouTube page, or you will anyways receive a link 7 to 10 days from now of the recording of today's event. So in case you miss out on anything, you can definitely catch up. So that's it from me. I hope you enjoy today's storytelling. I'd like to call upon Ms. Rania AlBanna. She's from Meinhardt Façade Consultancy. So she's going to be our event host for today and be taking you through until the end of the day. Thank you.
Thank you, Ahmed. Good morning, ladies and gentlemen. On behalf of Zak Exhibitions and Conferences, it is my pleasure to welcome you to Zak World of Façades, Dubai 2026. My name is Rania AlBanna. I'm a senior facade consultant at Meinhardt Façade Technology. And I am delighted to be your host for today's conference. We have an exciting program ahead featuring keynote presentations, technical sessions, project case studies, and thought-provoking panel discussions. Please keep your phones on silent throughout the entire sessions. To begin with our first lecture today, we look at how facade design is transforming before our eyes. Moving from architectural, storytelling, and expressive design language into advanced digital workflows powered by parametric design and artificial intelligence. Please welcome Edward McIntosh, Regional Design Director, Middle East and Africa, Atkins Réalis, and Alejandro Garcia Gadea, Lead Principal Architect, Atkins Réalis.
Good morning, and thanks for having us. Thanks for the opportunity to present our work today. Okay, let's start. So really, what we wanted to talk about for the benefit of our colleagues and clients and everyone who's involved in the built environment is a sort of a summary of what's happening in our studio currently. I think a lot of colleagues and clients are going through this same process as well, with the unprecedented speed at which technologies, including AI, are affecting our design processes. Me and my colleague Alejandro were using AI text-to-image tools, I think, from the beginning, almost 4 years ago. But one of the things, so we're big fans of it, but one of the things we want to put across is the fact that we still think the human intellect, and more than anything, the human intuition, is key for creating that result that is actually bringing something else to our society and especially to our culture. And here is where the aspect of narrative and having a narrative brief before we tackle the actual briefs we get from the clients, we believe is very important. And here talking about societal critic Eric Jorgensen talking about storytelling and the importance of narrative, right? Storytelling is the one thing that separates us from every other animal in the world, right? It's this idea that we can share these almost invented frameworks of mind that allow us to create things like huge organizations and the progress of culture, right? Importance of narrative. Number one, mass cooperation. The reason we believe in narratives is the reason why we have countries, for example, the reason why we use currency, US dollar, local currency, etc. Information retention, that allows us to build upon the progress of culture. That's why we actually progress, because these narratives allow us to codify the advances we create day to day and take them into the future, right? And social cohesion, right? How do we manage to have a world in which, yes, we have different cultures, different countries, but actually we work together as a globalized sort of entity, right? And very interesting, the last point, mental time travel. Our ability to invent scenarios that are going to happen in the future and that actually allow us also as well to put ourselves in the shoes of people who lived in the past. So what is culture? Culture is based on this passing down of narratives that are created by everyone. And so one of the things, personally as an architect, that I'm really interested is that we build all these things in the built environment that are quite costly, right, to manufacture, and they take a lot of effort and time. So I truly believe that these elements that we put into existence in the built environment should have an added value, right? And in a way should be actually enhancing what our culture and our society creates. One of the examples I'm going to talk to you today about, amongst others, is the design we did for the Muqab. We've been working on the Muqab in Saudi Arabia since 2021, when we won the international competition. And one of the reasons I believe we resonated with the chairman, His Royal Highness, and the board was that we imbued highly technological project, highly cutting-edge project, but we imbued it a lot with the narratives of Riyadh, because being that it was going to be meant to be the icon of the city and the country, we believe that it needed to have that underpinning of local culture. So we were lucky that we had won before the master plan for Diriyah Gate, and we did many projects there. So we were quite immersed into the Najd culture, and we studied quite a bit about it. So here just showing the sort of deep research we did in places like the Old Murabba Palace to understand what lied beneath the actual cultural manifestation of Riyadh and the Najd region. And basically, when we put forward the design that won the competition, it was all about taking hints from that historical past and that cultural past, but not only the superficial, but understanding how the original inhabitants of the Najd region actually came up with their cultural expression. So obviously, everyone who has worked in Riyadh and Diriyah especially has had to study this in terms of what are the components of Najdi architecture, which then evolve into Salmani architecture, right? And some of them, you probably think they're just visual sort of ornaments. But one thing I really like about Najdi, for example, is that every ornament that you see there was actually, or is actually, a functional element, right? So for example, the beautiful patterns on the mud render are actually there, so when it rains once a year, you don't get streaks on the mud render. Especially what I love is about the story behind the doors, right? Highly ornamental, very beautiful doors. But an old person from Riyadh was telling me that in their very labyrinthic sort of urban context, the very ornate doors were actually signage and wayfinding. So if anyone asks you for directions, you would say, go to the blue door with the red triangles and then turn and find the green door with the yellow circles, right? So just to say that sometimes we believe ornament is just ornament for ornament's sake, but actually in ancient culture, especially when resources were limited, ornament was really a functional tool. So with that in mind, when we did the new Muraba master plan and the Mukab, we really got in depth into making every aesthetic decision have a reason, right, in terms of its functionality. So one of the key inspirations for the Mukab was Salwa Palace in Al Toref, and the patterns that we see on what we call the Najdi screen are an evolution, let's say a modern interpretation of the patterns that we saw not only on the facades, but also on things like the textiles that were used throughout that area. And we added details like, for example, this corner detail that we have at the base of the Mukab that were a sort of paying homage to the ruins of Salwa Palace that have this particular profile. So just to say that even though it was a very futuristic design, I always like to say that it has one foot in the cultural narratives of the city that it represents and one foot into the future. So establishing that the way we work in the studio, it's initially generated by this crafting of narratives. My colleague Alejandro is now going to take over, and just to say, when the Mukab facade was designed, it was actually designed by me by hand, which actually made it very complicated in terms of resolving geometrically and making it ready for construction. And that's where the one foot on the human expression is mentioned, and then how do we actually make it practical in terms of a technical resolution.
Thank you, Edward. So basically what I'm going to try to do in a very quick way is trying to take you through some examples and some workflows that we developed to embed computational design, parametric design, and the latest AI, let's say, workflows into our intuitions as humans in the studio. And in general, like we like to always talk about like design as research, not just design for a specific brief, but like as a kind of constant evolving direction in the studio. So the first thing, just because we wanted to kind of touch base on the topic of the lecture as well on AI, it's a little bit talking about the different generations that we see in the development of AI and how we started from a tool, let's say the basic prompting that everyone have given a try with Midjourney and all these tools, where the AI basically has majority of the control, and then the human control is very much just reduced to the words that you are typing. So as we go through different generations of these AI tools, we can see that let's say like with stable diffusion, and I'll touch base very quickly in some of these workflows, but we see with stable diffusion, we can put additional inputs, and as we go to these node control design systems, we are able to capture a lot more information, and we like to say that it's almost like a painting, where the designer, the intuition, you put as much information as you have at the moment, and then the AI will try to help you to fill up the gaps where you haven't done it quite yet. So just kind of starting from prompting, so everyone knows like you have a prompt, you have an engine, and then you have an output. So you typically will have a number of questions. That's questions that you ask yourself, and that's how you structure your prompting. Just to give you a very quick example, so if you type a beautiful building, you will get what AI thinks is a beautiful building. So whatever the forum of internet decides is a beautiful building, that's what you get. You get more descriptive, then you start getting things closer to the result. Now, the order of the words is something that kind of can make a difference as well. So when we're talking about people in an office, if you put the office at the end of the sentence, the people will be more at the front. And then if you put the building description at the front, the image will most likely end up being a building. Now, that's not much of a control, right? So now what we've been working is developing a number of data sets, what is called more stable diffusion. And basically these data sets, what they are is like training models that try to get you closer to the type of images that you want to develop. So you have, again, data sets, a prompt, and a main image, an engine, and a result. So basically with a prompt, you will type, and you will get a building. But now with the stable diffusion, as a quick example, you will have a sketch, you will have a model, you will have a little mock-up, and then with that, as an input, like you can start controlling a little bit more the image. In a similar way, with a prompting, you could give a reference image, but you will not be able to keep the identity of the designer or the input of the designer, which was like these shapes that you model here. That will be taken as an interpretation or as a reference image. But then as you get more into stable diffusion, you are able to capture, okay, the colors are important for me, the outlines of the building is important for me, so that's what I want to keep. And then AI is trying to resolve that equation. Now, the interesting thing with data sets is like you can train it as bespoke as you want. So if you want to go like fully organic, like you will have been training a model that will deliver those images that are fully organic. If it's more into a different style or a palette of materials, you can start being very descriptive about it. So just to give you an example, this is just a quick test we did at the start, just for fun. So if you put like a basic prompt, like you have there, architectural design, small village design house, you put like different data sets and the results can be completely different. Now, just to explain how this works in the background, back to the same diagram, we are now adding these elements here, the control net. And the control net, basically what it's doing is like, we have a sketch, and that engine in the background is able to get you the outlines and get you the depth of the image. So it understands a little bit how it works in 3D. So that information is fed into the engine machine, and then you get your output image. Now, if we, okay. Yeah, so now this, I'm just going to jump into some projects that basically, very quick turnaround on the projects. We kind of, we have a clear design directions of elements that we want to keep, and that by composing the prompt in certain ways and feeding the right data sets and the right reference images, we are able to create consistent language across the building and consistent atmospheres. But basically like just kind of like quick modeling and enhancing with AI. So we have here a building reference for a tower. This is another project we've been working on in the desert of Lane. Master plan, just to give you an example, I can see I'm running out of time, so I'm going to try to be quick. So here, for instance, it's more about like, we have like 3 different facade styles that we want to combine in a master plan, and then do many different iterations in a very short period of time. So by using AI, we can test these ideas at a very early stage, get the feedback from the client, and then move on, and then try to make it work in a very compressed amount of time. One example, for instance, that it's been quite interesting is a number of facade studies that we input as designers. So we test a number of elements, and then those elements, through computational workflows, we feed them back into a tool that we've been working out with our cost planning team. And the information that is not yet available, AI is able to feed it into the system. So I think, again, like I would like to, if I had to summarize it, I would like to say that in a way, it's starting to become a bit more of a hybrid. It's not like that feeling that maybe, let's say, like the function as an architect, it might be at risk because AI is taking over. The way we see it really is an enhancement and a way to kind of compensate whenever you don't have all the information or whenever you are trying to test new ideas, AI can be there to support you. And then wherever your ideas are very clear, that's where the kind of human side will be the predominant factor. I'll pass it back to Edward.
Thank you, Ale. So getting into now more detail into the work my colleague Alejandro and the team helped me with on the mockup, since it was one of the most challenging elements that we tackled. Just to give you a sense of the scale of the mockup itself, it's like 4 city blocks of uptown New York. So I think that a project that actually escapes comprehension in terms of the scale of it. Just imagine this, 400 by 400 is 160,000 square meters per facade multiplied by 4, right? So quite a challenge. The whole point of the facade was that it looks quite regular because it has this triangular pattern, as I was mentioning, but as you can see, and that's why it was deliberately done by hand in the beginning, it does capture the sort of more organic, more natural cadence of ad hoc sort of creation, not a very sort of regularized sort of interpretation. So focusing on the facade itself, probably, again, the components within the mockup, just to re-emphasize the scale of it, 2 million square meters GFA. But again, I think the challenge the team went through was how to take that sketch that was very organic and almost poetic in a way and make it something that could be feasibly built. You want to take over here?
Yeah. So I'll try to break it down in about 8 minutes. Like the kind of challenge when Edward had like this beautiful Rhino model. It's all pretty, very random looking. And I was like, yes, I'm sure you have a system to do this. Send me the script. And it's like, oh no, there is no script. Like, okay, let's start from here. So I think the challenge, as you see, is to basically like, there's a number of elements that we see here. I mean, obviously, like there is a gradient that I think like that was one of the main elements that we have to preserve. So in the human scale, you are kind of approaching the building at one scale. So that thing here is about 10 meters, just for reference. So we're talking 400 meters tall. And then when you see these elements, the same triangles from far out, it's more like you're going to be looking at them from kind of kilometers away. So it's almost like a cathedral approach to a building where you want to see the grandiosity of the building, right? Just to give you an example, in numbers, we're talking, so it's about 7 meters depth, the facade, and we have a number of different screens, different elements. I'll get into that, but basically there are a number of mega panels. So the mega panels are like assemblies of all these elements that are done on the ground and then lifted up. So there are 6,600 of those units. It's about like 10 meters by 10 meters. Then these ones, they are made out of about like, I think it was like 200 kilometers of precast concrete panels of 0.5 meter by 300. So it was quite a challenge, let's call it. Some of the elements that were important on the design. So iconic element of the nasty screen, the idea of how the lighting will spill into the spaces inside. Another kind of very Saudi idea, or very Arabic idea of like framing the views. At the same time, this is all great, but you know we want to have real estate there, so we want to maximize the views. Constructability is not like we can build it all up as a stick system. Like we want to create as many assemblies and unitized elements as possible. And on top of that, we want to build the largest LED screen in the world. So it's like, okay, let's start with that. So in summary, what we are looking at is not a facade. It's like, I mean, it's actually the definition of a facade. It's a breathing skin. That skin needs to do things in the morning, do things in the night, needs to do things when, let's say, like it's a World Cup and people want to celebrate, and also when it's a moment of self-reflection. So all these different sides of the facade needs to be present there. Just to quickly touch base on a couple of challenges that we had. One of the challenges was two competing parameters. One parameter was a view, right? So we look at how these elements that were sitting in front of the facade affect your view. So look at the cone vision. So the closer that element is to you, you are going to be blocking more angles of your cone vision. So we were not looking at views just completely perpendicular, like you will typically do in a quick study, but actually in every single angle. So if you rotate your head around, you can still see things through. So how you cross interpret like the view analysis and the radiation that we were trying to do in order to get a glazing of the best possible qualities that we want to have. So we want to have as transparent glass as possible. So we took the basically from competition where obviously like we've designed a beautiful facade, but then views were not so much taken into consideration. So for something that was very blocked at times and very open at times, so here your radiation will be very high, and here your views will be very low. So we were trying to balance them out as much as possible. So taking, just as a summary, I'm just going to take a view analysis. Those were elements that had 0 views, and then some of the elements were completely open. So we tried to balance them out into a ratio that was agreed with our facade consultant. So now, when it comes to the experience here, the experience a little bit like being behind a masrabia, you are able to be high up on the sky, have beautiful views with this kind of view analysis that we had, but at the same time you've been shaded by the different layers of the nasty screen. Now, in terms of lighting, like we had many studies about the lighting, and there are 2 different lightings. One thing is the architectural lighting. So basically, if you think about a building like Burj Khalifa, one thing is during a normal night day, and then the other thing is when you have like showtime. So showtime, we will be looking at this LED screen sitting at the front of those precast concrete elements, and during the architectural lighting will be a bit more of a subtle lighting, just enhancing the depth of the nasty screen, which is the image I was showing before, when it's no showtime. So that kind of combination of elements was also kind of interesting to develop. And now just a little bit more back on the workflows. So obviously there's an intuition. So that's all the intuition that Edward brought into developing that beautiful scheme. Now that scheme, we need to start breaking it down into elements and starting embedding control. So for that control, we used those computational tools. And if I go back here, we basically will start with a number of elements and curves that translate into 3Ds. And then that's the part that is kind of quite interesting there. So we develop a number of metadata. So each of the elements had an ID and a number of attributes assigned. And then through Power BI, Excel, and different tools, we were able to control each of them and work with the client as well to not only maximize the views and reduce the radiation, but also try to, let's say, introduce as much repetition as possible. And then that was then translated into a Revit model. Just to give you, again, in 2 slides, a bit of the ideas on these elements. So the elements were very unique at the start, but then we started rationalizing. So we have 5 different grids that were almost like fractals, and at different scales, they will kind of be subdivided into smaller grids, and the main idea is that each of the elements could be eventually translated into triangles and parallel curves. So you take different portions of them, and you started creating all these nasty characters that made up the different combinations that you will see on the nasty screen. So now those ones were also distributed across the facade with these evolutionary algorithms to have a balanced facade for radiation and views. And the profiles will also keep a gradient, but still keep only 5 different profiles to avoid having excessive number of different elements. That's just one example of what I was talking about. So if you take that element here, so that will be corresponding to a band here on the 3D that is number 3. It will have an ID, and then we'll have its layer, the length, number of elements, orientation of the facade, the plane where it's located, the profile, the rail, and the volume. So now you take those elements, and then basically you start building up a unitized system made out of elements that in theory looks completely random. I'm running out of time, so I'm just going to skip through the section with some of the elements, and then I think this is an interesting one. In terms of constructability, our thoughts were basically here. So you have a number of elements done off-site, you bring it to site, you have a pre-assembly station, and then each of these assemblies, remember there are 6,600 of them with quite a lot of repetitions, they are then lifted and then being installed on the curtain wall. That's some of the facades, and then basically like we have here, the package being documented with a start on the intuition, and then with the enhancement and assistance, let's say, of the tools that are available, computational design tools, parametric, and these AI workflows.
Great. Well, thank you very much. I just wanted to put this slide before we finish for next year. One of our dear colleagues, Mohammed Fatih, has just done his master's degree on something based on something that we always talked about in the office, how to scientifically measure beauty on the street front of our cities. So I'll leave it like that, and yeah, see you next year.
Thank you.
Thank you for that insightful presentation. Our next lecture brings together expertise from AESG and Kila Design. Please welcome Marina Kindelan Calvo, Director of Façades, ME, APAC at AESG, and Oana Fayyad, Senior Architect and Kila Design.
Good morning, everyone. Well, first of all, I want to thank Zak Façades for having us here. It is really great to hear that actually they finally managed to get the event, because for me and for most of us, it's a really nice time to spend time with the colleagues in the industry and to know more about what is happening and what everyone is doing. Today, we are going to be talking about the architecture of the inevitable design, the discipline of clarity. I know it's a little bit confusing, the title. I hope that at the end of the presentation, you will understand the concept.
Hopefully.
The idea is that today, we are going to share the stage between Oana, who is the Senior Project Architect at Kila Design, and myself.
It's not working.
Yeah, it's not working? So, well, I will keep talking.
Now it's working.
Now it's working.
Yeah, sorry.
So the whole idea is actually that we explain what is the process that some of you will be familiarized with, that is when architecture and engineering put together all the efforts to actually get to a really iconic design and to push the limits. So at the beginning, Oana is going to go through some of the projects that Kila has worked, and they're really iconic projects, and it's going to go in a lot of detail on those ones. And then, apart from that, we will then go in detail to one project that Kila Design has worked together with AESG and go and talk, and talk about some of the areas that we found intriguing, where we actually pushed the limits and we discussed and found what I consider an optimal design. So, Juan, I pass it to you.
Thank you, Marina. So I think, just to start with, thank you for having us, like Marina said. The way that we usually tackle our design in general is many people might see the facade as just the outer skin of the building. For us, it's much more than that. It's where architecture meets engineering, and it's usually where innovation happens and where you have room for creativity. Now, I think some of you have already visited this place, or I hope you have, and if you have, I hope you enjoyed. One of the biggest challenges that we faced at Marsa Al Arab is how do you actually continue a legacy without repeating it? And how do you create something new while respecting what's already there, which is one of the most iconic buildings, even in the world, we can say, which is the seele, Burj Al Arab, and then you have the wave, which is the Jumeirah Hotel. The way that we found that this is possible is purely through precision. Now, what we've done for this project is not only did we separate the two buildings to allow for a precise location to ensure that wherever you are in Dubai, you always have a view of Burj Al Arab, and we respect what's already a legacy that's been built by others. Now, actually, AESG did the facade access on this. We gave them a very hard time. I'm sure Marina will tell you all about that.
Can you? Yeah. In this project, I don't know if any of my colleagues are here who has worked in this project as a facade access consultant, but it was really complex because, of course, the facade access strategy couldn't interfere with the architectural design. And for anyone that knows how facade access works, usually it goes either from the roof or from the ground, which, as you can see, from the roof, that was not an option, and from the ground, with the amazing landscape that they were designing and they have done, also is really intriguing. So mainly, I will say we could have spent at least 1 or 2 hours just to explain how actually facade access works in Marsa Al Arab, because it's been detailed almost room by room, apartment by apartment.
Yeah.
So yeah.
But it works. So I think one thing to note about the arch that you see in the driveway, which is one of the most magnificent points where you actually drive up and you see a direct view of Burj Al Arab, is that this is about a 16-meter high, 36 meters wide truss, where it actually weighs about, if I remember correctly, about 3,000 tons of steel, which is almost equivalent to 1,000 elephants. So this is a big piece of engineering work that had to have a lot of collaboration happen between us and the engineers on board. The balconies are also self-shading in the way that they've been detailed, which allows about 40% of reduction in the consumption of the building. Now, moving on, what craftsmanship does is that it creates trust, and that allows for us, gives us room to create freedom to focus on the human experience. I think you've all seen this. This was one of the most interesting site visits so far, and as you can see, there's a lot of marine life that we had to make sure is preserved on this, which is why we needed to ensure that what we're doing preserves the beauty of the environment. And that's why it needed to be a canvas that actually reflects the ever-changing colors of the sky and the movement of the water. This was the idea, to have the master plan look like a string of pearls that goes all the way through the Red Sea. Now, this was a very, very interesting construction. We did several mock-ups on this. This was actually fabricated in Sharjah and taken by boat. So it was built off-site and brought to the Red Sea. That also helped protect the marine life that is happening under. Now, as you can see, the structure of it is what creates the pearl-like look. But I think what's more interesting is the detailing of how this has been fabricated, which I'm not going to go into too much of, but it's connected from the inside, and you have a stainless steel around it. So you have absolutely no seams or joints on the outside of the pod. It is a fully polished pod all the way around. And I think we did achieve the fact of making sure that the beauty around it is reflected through the architecture and it's not competing with it. Now, before we move to the last project that Marina and I will talk about, I'm sure you've all seen this, and this had its own set of challenges, which is, how do you represent the future in a museum? Which is a very tough question, right? It's a very big ask. So looking at the site, one thing that we realized quite quickly is that we have to go away from convention and start asking difficult questions, which is, first of all, we realized this has to be a vertical museum, away from the two-story conventional museums that you usually see. That's number one. And then we looked at what is really the future. So for us, the most important part of this design is actually the void, which you see in the center, which represents the future itself and the unknown, because none of us can predict the future, right? But what we did is provide space for that future to exist and provide an actual allocation where innovation and progress can happen. These are some of Sean's sketches that he was doing at about 2 a.m. in the morning, getting sent to us. I think one of the most complex facades maybe in the world is this building, where you see a steel diagrid that works together with the facade on the outside to actually create the form of the building. So everything is one. This actually had about more than 1,000 unique pieces on the facade. Now, to make that even more complex, there's a calligraphy on the outside that needed to exist, which were actually the words of His Highness that we wanted to place on the building itself. Now, the reason this was important is there were so many iterations that had to happen to make sure that where the openings are away from the nodes of the steel structure, and that it's big enough to allow light in, but also for people to walk through and experience. Now, last but not least, this is the project that we need to talk about and to focus on. Now, Priatoni Tower, one of the main challenges of this project is that we needed a residential tower. We wanted to create height. Now, in the conventional sense, how do you create height? You either make the building more slender, which makes the floor plate a lot less efficient, or you add more GFA. So this is where we reached to our actual conclusion, is why don't we just create space within the building? And what can these spaces actually be? These can become elevated gardens that are in the heart of the city. This is Business Bay. Now, this as well presented many sets of challenges that Marina will go further into.
Yeah, so again, I think we have seen from the previous projects that Oana has presented that Kila has their own way to actually approach projects, and they have created iconic architecture through that approach. So here is a great example. Those sky gardens, I'm pretty sure like majority of you have seen sky gardens before in other projects, but the way that they have approached that concept is completely different. It's not a void in the tower as per the sketch that she put in the screen before. It's actually the whole facade. These things are embracing those spaces and emphasizing that. With that, of course, it came certain complexity or certain challenges where is where the fun comes between engineering and architecture.
It was very important to us to understand how we actually create the architecture around those sky gardens so that it is resembling the nature that it involves, but also maintains the integrity of the engineering and the technicality of it.
Yeah. So go one before, because I really want to emphasize one of the complex coordination between us. It was this curved glass that I'm going to go in detail in the next slide. That curved glass, it was really important, and it was crucial for Kila to make their design to work. So we tried to do absolutely everything to not change the architectural intent, but at the same time rationalize and optimize. If you can go, sorry, thank you. So what had happened is when we took a section through that curved glass, we realized that every single panel was a double curved glass panel. The reason for that is because the curvature was not created by a circumference, it was created by an ellipse. So it was kind of a quarter of ellipse. If you remember the previous image, that will be kind of what you see the curvature. So that was one of the things. The other one is in the corners. The radius of that double curved panel was really tight. We will reach around below 1.5. And then we have also the fact that some of these curved glass panels were overhanging. Therefore, there was some safety concerns. So how did we, as a team, solve this issue? So we start to look into the geometry, simplifying that. So we went back to this ellipse, and then we tweak slightly the shape of the ellipse to be actually responding an ellipse created by two types of circumference. The big circumference that you have on the bottom right, and then the small one that is on the top part. So what we have done is introducing an intermediate section that divides the curved glass panel into two curved glass panels with different radius. Again, what that has done is that we didn't have a major impact on your architectural design, but we optimized the panels as much as possible. These are some of the details corresponding to what you see on the image. So as you can see, the introduction of this transom has created these two panels as a single curve panels because each of them represents a curvature. On this, with that exercise from, well, I don't know if it's too clear because this diagram is quite clear for us because we've been working in the project, but this represents the two sky gardens, and then we analyzed together every single glass panel on that area to see if it was double curve or single curve. As I mentioned at the beginning, all of them double curve. We managed as a team to reduce that to just having double curve at the corner interface, well, at the corner elements. So, yeah, do you want to add anything on that?
Yeah, which is actually 4% of the building. And I think it's important to just note that this is one of the examples that you really see that when a vision is clear and the idea has clarity, it remains intact through the hands of everyone who touch it. So AESG have been the best partner on this to ensure that the initial form of the building and our initial idea is not gone to waste. And I think that's very important for us to preserve in our industry.
Yeah, so again, we already simplify, but there was one thing that when we start to discuss with Kila, it was the detail, the build-up of the glass. We had three types of, well, we had the curtain wall, we have the single curve, and then we had the double curve. One thing that it was clear from the architectural point of view is that we can't have different coatings, different build-ups for the glazing, especially on those curved areas, because, again, just going back to that image, if you remember, that those curved glass are to human eye. So the people, when they are in these sky gardens, they are going to actually see those elements quite closely. So we didn't want to have different coating, different build-up on a glass that it was the single curve, and then a change and a different one on the corner ones. So the whole design of the glazing on those areas was triggered through those corner elements, where the radius was really minimum. We managed to Kila and AESG managed to actually change slightly the shape to get to the minimum requirement in terms of the radius. And then from that point, we started to decide if we were going to go with the heat strength or with fully toughened. In this case, for the corner elements, due to the corner elements and the small radius, we had to go with the heat strength. In terms of DU, which was the initial idea, and single glazing, we had to go for the single glazing again because of the constraints and the complexity that it was going to be added onto the design. In terms of laminated and monolithic, the whole analysis was done for safety and thermal stress, because again, those ones, if you see them, one of them is on an spandrel area. And then in terms of the thickness, our engineering team had a little bit of fun, because it's where you balance the thickness for the structural performance with the thickness that allows you the curvature. So you need to actually get the optimal thickness that allows you the curvature as per the architectural intent, but at the same time it performs as required. So all of that, none of these decisions has been taken as a facade consultants entity and completely separate. It's been a whole coordination. So this is why we wanted to have this presentation and do it together, is because none of the decisions that a facade consultant does is isolated, because it has an impact in the architecture. And none of the, well, not none, but what we like from this collaboration is that when Kila has a decision or an intent, they come to the engineering team to see how to make it possible. So,
And I think the Sky Garden proves it's one of the most important spaces within the tower, because we wanted to make sure that that elevated garden, although it's within the heart of the city and it's at a scale that is not quite human if you call it from the ground floor, but the experience itself is quite human. And we wanted everything that has to do with the senses to be engaged, from your vision, when everything that you see is around you is perfectly detailed, to the sound of birds that come on the trees that we're planting, the sound of your footsteps on the gravel. Everything is to engage the senses. And this is why, as Marina mentioned, the detailing on that specific part of the building is the most important part of it, because there's no in between. You either get it right or you don't. I think just worth noting that another one of the challenges that we were facing on this building in specific is, if you see on the lower part of the building, you actually have balconies, whereas on the top part of the buildings you do not, which we will get to in a second. And what that created in terms of technical complexity is that the curvature of the GRC fins that you have around and the curvature of the glass are different, but they also need to be exactly the same to work on the top of the building as well as the bottom of the building. So whatever solution worked here needed to work here as well, which was not always the best for the other, until we finally found a solution that works for both. Another thing to note is the balustrade was placed on the outside of the slab, which was quite important for us. We needed to ensure that the horizontality of the slabs are dimmed so that the prominence of the building is the verticality and the sky gardens.
All the decisions, and as I've been saying, all the decisions that Kila has had, their input and how in detail they go in terms of the engineered solutions, it actually has created the previous projects that Oana has shown as iconic projects and really good end quality. So on this one, definitely is the same. They've been pushing the limits. So that doesn't exist a no to Kila. Is like, okay, how we do it together. That I remember also some of the discussions about decapping, because some of the curved glass, as I mentioned at the beginning, it was overhanging. So we had to have some mechanical restriction to that one. And it was a lot of the discussion, and really the architecture team went into detail to look this capping that is barely you can see it, because they didn't want to have that impact. They didn't want to have that visual impact. So I love it, and I think the great solutions comes when an architect gets to that much of detail.
Coordination with the engineers, 100%. And I think, And I think one thing worth noting as well is when you see this building, one might possibly think that there's transfers, that the structure is not very efficient, but the way we work is a building has to actually function. It's not purely a form, and having a beautiful form does not give you the free pass to not have it engineeringly and technically sound, which is why you see that this building is actually very structurally efficient. Your columns and your shears go straight up from the bottom to the very top. And the reason why the fins on the building are placed where they are is because they're following the modularity of the structural grid, which is, again, a coordination that we had to do with our structural team to find the best distancing between the columns that also creates the rhythm on the facade that we would like to have with the fins. And last but not least, one of the elements in this tower that we are quite happy with and proud of is the introduction of a Juliet balcony, which you don't see quite often in this region. It's usually your typical balconies. Now, what we like about this is the fact that your internal living space, obviously, when the months allow, can become your completely outdoor space. And it's a human scale experience. It's a different type of residential amenity, let's call it, that has not really been done here. And that created another set of complexities that Marina will go into more detail of. This was, again, one of the really tough ones to solve, especially at that high level.
So in terms of the Juliet balconies, it's a system. So we will think when they came with that idea that, well, amazing idea, great idea to incorporate in this region. A lot of times balconies are unused because of the dust. The fact that you actually can decide when do you have a balcony and when it's internal space, it's great. We didn't see any complexity at the beginning until we start to realize that some of these Juliet balconies are not exactly, well, you can see it here, it's a double height space where we didn't have, in some of the spaces, we didn't have intermediate support. So we had to reinforce, as you can see, I think in the section that is there, with a steel, really quite thick and big steel stiffeners, because we didn't want to have any impact on the section, because again, it will have a big impact on the internal design. At the same time, it's how you coordinate, how you design, how those Juliet balconies operate to make sure that cleaning, maintenance, and the access of the tenant is smooth. Same, again, that Juliet balcony, again, on the section you cannot see, but in some of the cases interface with the GRC fin is how do actually, what is how the end user is going to see it, how it's going to affect the end user, if any, and is that coordination, that day-to-day discussion that allows to end up with hopefully an amazing apartment with that comes like the living room all of a sudden is your amazing balcony. So yeah.
So just to conclude, if we're looking for the best solution to solve an existing problem or to use the existing constraints that we have, and we look at that with clarity and courage, the design becomes inevitable. It becomes really clear the choice that you have to make and what direction you have to go into. Thank you very much.
Thank you.
Thank you, ladies. Please join me in welcoming our next speaker, Ralph Damkoehler, Managing Director, Seele Middle East, presenting Kinetic Moving Architecture Forward.
Seele is well known for complex, innovative facades and building envelopes. However, today I would like to speak about movable structures related to facades. And I would like to introduce you to Cele's division called Kinetic. Good morning, ladies and gentlemen. My name is Ralf Damkoehler. I am nearly 10 years with Seele. I'm the managing director of Seele FZE here in the Emirates and Seele Contracting in Saudi Arabia. Facades are no longer static. We are moving forward and implement wishes of the users and environmental scenarios. We therefore have established a new division at Seele called Kinetic for movable structures. The principles are based on first pivoting, that means returning around vertical or horizontal axis, and second on linear movement in specific direction or along predefined paths. Seele Kinetic merges two worlds. One is the world of automation, which consists of cutting-edge drive technologies, intelligent control engineering, safety concepts, intuitive usability and interfaces, as well as acoustic performances. The second world is the classical facade construction world and contains outstanding design, structural precision, glass materials and surface qualities, as well as high performance requirements. So Seele Kinetic is specializing in unique solutions, pushing the architecture on the next level. And this brings us to our motto, moving architecture forward. All this is followed by Seele Kinetic during concept development, which we do together with the client's team, during design, during performance of in-house and third-party testing, during fabrication installation of mechanical and control elements with regular quality control, what is very important, and of course during final commissioning of Seele Kinetic facade or movable roofs. Our first experience with movable structures we had already before we established Seele Kinetic. The project was at the Apple Park, and these were restaurant doors, movable doors. The architect was Foster and Partners. We have two movable door wings in the restaurant area, and they connect the entire space with the surrounding landscape. The width of each door leaf is 28 meters, the height is 16 meters, with a weight of 180 tons. It takes 12 minutes to open or to close the doors, and the maintenance team confirmed that they open the doors nearly daily, and they are working silent and smoothly as on day one. In case of power failure, a cordless drill is sufficient in order to close or to open the doors. The next project is a lift-up facade. It's a private residence in London, and the project was completed in 2024. So the facade element is nearly 11 meters wide with a height of 2.2 meters, and it takes 2 minutes to open the facade element. It merges completely into the building, and it uses active pneumatic technology, so it is controlled by air pressure and inflates when it's active and deflates when it's opened. When we speak about complex drive mechanisms, smoothly and reliable operation is the most important thing, because they need to work not only once but during the whole project life. A landmark project of Seele was the Sphere in Las Vegas. The scope of Seele here was the design, installation of substructure for the internal LED screens. The LED modules were in the size of about 4.5 by 5 meters, and the most challenging item here was the tolerance. The tolerance between the LED modules was 0.5 millimeters. Otherwise, you would see white or black stripes when there are performances. One package included in the Sphere was so-called proscenium screen. You see here the principle, how it works, and here you see the entire screen. We have 6 trusses and 126 LED panels. All these structure can be removed and assembled again. The purpose is that heavy stuff can be brought to the stage before performances, and of course it shall be reassembled again with the tolerance of 0.5 millimeters. Another feature in the Sphere were the so-called rigging hatches. They are used during performances for special effects. You can drop balloons into the scene, and of course they also need to work as silent as possible and smoothly. Another facade is a drop-down facade. This is opposite to the project in UK. So the total facade element drops into the ground, and this is a perfect example for seamless design coordination and invisible technical integration. So remember, we spoke at the beginning about performance requirements. We did a mock-up here with 7 different configurations. We did performance mock-up and tested it against air and weather tightness, including wind test up to hurricane strength. And to understand the behavior of the system, we did several cycle tests. I think I have to hurry a bit. Last project, which brings us from movable facades to movable envelopes, is the Allison Institute of Technology in London, in Oxford. The architect also Foster and Partners, and here we did a design, fabrication, test and installation, or installation will be this year, of a double skin grid shell dome, which moves around his axis. It provides sun shading by shading lamelles. It takes altogether 10 minutes to turn around, but the sun tracking is realized every 30 minutes, and it provides better atmosphere in the library, which is below this dome. Of course, we had to hide the drive mechanisms. There are 4 synchronized mechanisms. Yeah, I'm coming to the end. So the result of Seele Kinetic are high performance and dynamic building envelopes, and we set new standards for architecture and engineering. Each new project is its own unique challenge and almost with zero repetition. Thank you very much that I could introduce you to Seele Kinetic.
Thank you, Ralph. Our next presentation focuses on high-performance glazing solutions and the role of bird-friendly glass in contemporary architecture. Please welcome Ahmed Abuhashem, International Projects Manager, AME at Guardian Glass.
Good morning, everyone. Thank you for joining us today. So today I will be talking about designing a high-performance glass facades. During the topic, I will be covering three main areas: the bird-friendly, a real case study for a project and how the glass can be part of the design and support reaching or achieving the design intent. And the last point would be the digital tools and how it can support architects and designers. All right, so maybe bird-friendly facade and bird-friendly design might be a new topic for some of the people, and why this topic matters. So actually, the bird-window collusion is one of the global issues that we are seeing, and mainly because birds can see the reflection of the skies, reflection of the trees, or even the surrounding scenery, or even they might see through the glass and think the path is open. And in the modern facade, we are using more transparent and more reflective glass, and that's why this topic is becoming more relevant. And as you can see here from the map, this topic also is matter to the UAE, also to the wider Middle East region as well, since there is migration routes for birds as well. So today, facade is not only about like aesthetic or performance, but also the biodiversity become part of the conversation as well. So just to give you like an idea about some of the methods or the misconception ideas, it's a common misconception ideas related to the bird-friendly facades. So for example, many people will assume that window collusion only happening in the big cities, but actually this is not true. So regardless, is it like urban, suburban, or even the low-rise buildings, whenever there is a reflection, birds cannot identify the surrounding, the collusion might happen. Another misconception that one solution can be used in all the projects, but also this is not true. Every project is a unique project, depends on the location, the lighting conditions, and that's why each project needs a unique solution as well to be able to achieve the needs of the building. So another also misconception that the bird-friendly glass or bird-friendly solution might not achieve the aesthetic requirement or might not be pleasing aesthetically. And that applies not only external, but also internal. And this is not true, because today with the modern solutions that is already available, it's a wide, flexible and solution that the pattern, for example, can be part of the design of the building. Another point that even like most of the solutions from a distance, you cannot see it. And this is applicable even internally from inside the building. So many of these solutions can be even combined with the solar control and thermal control and high performing coatings that will help whoever using the building still to enjoy the views and having thermal performance as well. One of the other misconceptions that maybe using a few stickers on the building can be enough to deter the birds, but also this is not true. because like the solutions effectiveness depends on many aspects. For example, the brightness inside and out, the complexity of the surrounding scenery, the surface that we are using the solution, it make also a difference. The distance between the patterns and the elements. So I would say, generally speaking, it's very important to design a facade that is being readable to the birds to reduce or to eliminate the collusion from happening. Okay, so this is here, like I would like to take about a project in New York City called 70 Hudson Yard Project. And the most important point here that the topic of bird-friendly changed nowadays from being it's a nice thing to have in your project to be it's more requirement and the compliance in many of the cities around the world. So for example, in 2021 in New York City, there was a new local regulation called Law 15, which requires any new building or major renovation buildings to have a bird-friendly solutions. And that I think at certain point we will see it also in our region. So again, so bird-friendly solution, it's not only for environment, but also it's related to the sustainability. So there is many solutions available. So for example, we have what we call the bird first solutions. So from having a bird fretted solution, which is basically a ceramic fret, to bird first etched, which is a basically translucent acid etch, to one of the latest innovative product, which is the bird first UV. So all of these solutions are being tested with the American Bird Conservancy, ABC, with threat factor of 30 or less. So that's all of them considered as a bird-friendly solutions. One of the unique things about the UV coating that the human eye cannot see it. And that's why I said each design, we can fit a bird solution within the design. And even if we want to have like the best view ever, we can use one of the products like the UV coatings. And the bird-friendly solution, it's not only either to preserve the birds, but also it can be combined with other coatings that will provide the performance and helping to have a high-performing building like the double and triple silver coatings. Okay, so moving from a challenge like the bird-friendly facade to a case study and how the glass can be integrated and support the vision of the architects and designers in the real life. So I will talk here about Rania Living project. I would like to start with the project location. As you can see here, the project is located in Jumeirah Crescent. It is a high-end residential project covered with more than 80,000 square meters of glass, double silver coating. So we always see a big value of interacting and working with all the stakeholders in the projects, from the developer, the design team, to even main contractors and subcontractors till we work with the glass processors. And the main reason here that we wanted to understand what's the intention of the design and how can the glass selection integrated in the design and support the architect and the client needs. So just to give you an idea here, the design was inspired by the seashell, from the colors to the lines, which was reflected on the balconies. The selected product here contributed in achieving the architectural vision, the aesthetic, and also the facade performance. And I will give you like more ideas in the next slides. So in any iconic projects, it's not only today, not only about selecting the right glass. the need goes beyond the selection of the glass to even to the quality. So one of the challenges we are seeing nowadays in the modern facade, the optical quality and the distortion. And that's why we came up with a program we called SOQ, or Select Optical Quality. So actually the SOQ program is designed for the high profiles projects that is demanding an extraordinary, I would say, quality. And that's starting like to set the right quality for your project. It starts from the design, but honestly, whatever is being done on the design is not enough. So we are extending the support even before the execution to make sure that we can evaluate and support the awarded glass processor, certified glass processor, make sure that we are checking the availability and validity of the certification, like the IGCC, the scanner tools they have, the spectrometer, and also that's going until the production. So we are supporting with the quality processing, the quality of tempering, the distortion measurement, and all of this being reported and submitted to the projects. So here, why we are doing this? Because the standard, the international standard, is wide and is not enough. So we have tightened this and provided that from the design stage to the clients till we reach to the glass processor to make sure that the best quality can be offered to the iconic projects. So here, just to back to the project and how the glass selection contributed. So first of all, like with this premium location, the requirement was to have like a neutral gray appearance from outside. The project is overlooking the sea, so we wanted to make sure that, and that was also the design intent, that whoever is using the building can enjoy the views from inside. So we have used SN Gray 50, which is giving a neutral gray appearance. And it has a 15% reflection, or lower than 15% reflection from indoor. And to give you like also an idea of another topic as well, which is the performance of the acoustic performance, which is offering more comfort to whoever is using the building. And at the end, as you can see, the project overlooking the sea and also overlooking other landmarks like Burj Khalifa and Mars Al Arab, which we are proud to supply glass to both of these projects. Okay, so depending on which part of the project, it needs like also a special solution. So for example, in the podium of the project, the architect and the client wanted to make sure that the interaction is happening, the maximum light transmission is being delivered, and the lowest reflection can be achieved. So we have used a product called the Clarity, Guarding Clarity. So Guarding Clarity basically is an anti-reflective coating. And to give you like insight, like for example, the 6mm clear glass has a reflection of around 8%. With this product, we can reduce it to be lower than 1%. And also, like such of an innovative product can be combined with other double or triple silver coatings to provide the maximum visibility and to improve even the thermal insulation of the building. Okay, so that was the case study. I think that the glass still play a main role in all of the projects and the buildings. The most important point is to understand what is the intention of the design and how the selection can contribute in achieving this. Moving to the third part, which is the digital tools. So actually, we wanted to support the architects not only by providing like a data sheets, but now the world is moving more digitally, and we wanted to be part of this. And actually, we have invested heavily in many of the digital tools. One of these tools is the AI. I think AI is one of the very popular topics nowadays. I think many of the architects and designers wanted to achieve the information or to find the information they might be looking forward day or night regardless. So we have come up with a tool called Claria AI. It's a AI-powered tool assistant for Guardian Glass. It can help architects and designers to answer any technical question, to recommend the compliance glazing solution, and even it can help you to identify the closest glass processor to you and can guide you to the proper resources whenever you need it. The more interaction with the tool, the better the results you will get through the tool. Beyond the Claria and the AI, we have a digital platform, a huge digital platform. So we wanted to help the architects and designers and even anyone who might be interested to have more details related to the glass digitally. So from having the project locator or even an e-learning platform, project showcases, the performance assistant and performance calculation to visualization. So I know that many of you might be interested to see how a piece of a glass will look on a building. So that's now is possible with the glass visualization. Digital selector, also like you can provide what you are looking for from light transmission, U value, and you start to get like more what is the products that can be support you with the products. To the specification and BIM, which is also something we are seeing a lot of demand on the BIM and the digital tools, specification, documentation, along the way till our direct customers placing the order. All of this can be achieved digitally. So at the end, I would say Guardian Glass is committed to not only provide projects with a beautiful glass products, but also we are committed to help the architects to select glass that will help them in improving the performance of the building, but even though, and more than that, to build projects for future. Thank you.
Thank you, Ahmed. Parametric modeling continues to transform how we design and optimize facades. To discuss how digital workflows can connect geometry, energy performance, sustainability, and cost, please welcome Jincy, Mariam, Rinu, Middle East facade leader, Arup, and Elia Galatolo, senior facade engineer at Arup.
It's okay.
Is this? Yeah, okay. So, good morning, everyone. It feels so good to be back at the Zak this year. So before we go into the technical presentation, allow me a couple of minutes to set the context and introduce us. We are Arup. We are a global collective of designers, engineers, and specialists bringing together creative and technical solutions for the built environment. So at Arup, we often say that our work is meaningful only if it contributes to something greater than the project itself. A thought that has been strongly shaped by our founder of Arup, who believes engineering not just to be a technical discipline, but something that should bring together architecture, creativity, design, and social impact. This thought has now led to what we call as total design, an idea that architecture, construction, and design are not independent, but something that should be integrated from the onset to ensure the best outcomes. Today, we are a global organization with multidisciplinary 18,000 plus employees spread across all around the world offices, yet set up in such a way that it allows us to seamlessly collaborate and share knowledge to ensure that we get the right expertise for every project that we are involved on. Our Façades has been in practice since 1989. We are a global collective of 300 plus specialists working across project typologies, climatic conditions, and regions. At the same time, we do have strong local presence here, which means that we get to support project teams from the onset up until construction and delivery. Now, in facades, I believe that this way of working is particularly important as we sit at the intersection of architecture, MEP, building physics, building performance, sustainability, and many more. In the Middle East, in fact, this is even more pronounced because we are facing challenging environmental conditions, ambitious architecture, complex geometry, and at the same time, projects are becoming more and more fast-paced. A growing thing that we are seeing in the region right now is the shift towards retrofit and refurbishment of facades, with the focus shifting from demolition and new build to extending the longevity of buildings. This means that there is very small room for error at the delivery phase. And this is where we bring clarity into that complexity. And this is where we believe that we at Arup add value through our approach of total design, global collaboration, and knowledge sharing. I will now hand it over to my colleague Elia. He will take you through how we put this idea of ours into practice and how we integrate this within our projects. Thank you.
Thank you, Jincy. It's working?
Yes.
Okay. Good. So, as we know, during the early stages of the design, what happens is we have a lot of people, a lot of entities that needs to interact with each other and sharing constraints and information. And usually these constraints and information are strictly related to each other. Especially if we focus on facade only, we already have a lot of variables that we need to deal with, from the G value, the U value, the facade zone, embodied carbon, a lot of things. A lot of these are strictly related to each other as well. So the window-to-wall ratio has an impact on the G value has an impact on the thermal performances, on the energy performances, on the cost, and so on and so on. So this makes the design process an iterative process. So if we think on how the usual design process is working, is that we have a facade system, we select a facade system, this facade system has certain facade performances, then we plug these performances in the building performances, and we ask if this is actually meeting the targets that we set. If no, we go back, we select another facade system, we update the performances, we update the building performances, and we continue until the whole system is approved. And this, of course, is costing a lot of money and time. So we should ask ourselves a question. Is there actually a way to improve this workflow? So usually what we do is we start with some inputs, we run some calculations, and then we end outputs. So wouldn't it be great if we can actually flip the process and our outputs becomes our inputs? So we thought, what if we start defining some building performances, some targets that we want to achieve, and some facade performances that we can actually have. So we put together everything in a single parametric model, we run it, and we achieve thousands of options. So what we have to do at the end is just filtering and narrowing down the one that we know works and that are already approved, and then we can submit what is left to the design team so that they can pick the option that is meeting the design intent. So to summarize the process, what we can do, and what we do, is sitting together at the beginning of the project with the design team, the architects, the client, the engineers, and we set the variables and the parameters that we want to achieve. So once we set all the parameters, we then try to simplify the whole process to reduce, for example, the computational time, to optimize the model. We create the model, and then once the model is ready, we can meet again the design team, and we can work on the outputs and select which are the options that are actually meeting the technical requirements and the architectural requirements. So to demonstrate the efficiency of this methodology, we are bringing two examples that we developed during the last year. One is 130 Fenchurch Street, that is a building in London, and the other one is a zero energy research and development campus that we developed in Abu Dhabi. So the first one is mainly focused on energy consumptions, sustainability, and glazing ratio. The other one is more focused on geometry optimization and shading finding. So if we focus on the first one, the list of inputs, yes, they're visible. The list of inputs that we analyzed started with the U value, so we tested different performances, different build-ups For the facade system, we tested the different window-to-wall ratio, so different sizes of the windows for the different orientations, and we tested different G-values as well. So we used the G-value to set also the facade system. So for example, we had a single skin, we have a single skin with eternal blinds, and we also had a double skin. In terms of outputs, as I said, we focus mainly on energy. So we had the annual cooling energy that is setting us the targets that we can achieve, like BREEAM or neighbors or whatever we want to achieve. And then we had also the cooling peaks for the local comforts. And then, of course, also sustainability and all the carbon consumptions, like embodied carbon, operational carbon, and so on. So as I was saying, the G-value, we use it to set it the facade system, and then we link it directly to embodied carbon to have a direct relationship. So if we, overall, we ran about 3,000 combinations, over 3,000 combinations, combining all these inputs. And if we gray out for a second the one that were related to the technical performances, and we couldn't change, and remove almost half of the combination that we run, we are remaining with the actual variables that we can play with. So we sit together with the architects, the clients, and we understand on a scale which are the one that needs to have a major impact. In this case, as we said, the window-to-wall ratio played a bigger role. So how do we actually manage 3,000 options, though? So we do in Arup, we're using our in-house tool is Inform. I'm playing here a quick demo. It works pretty simple. We have on the left side the inputs, and on the right side the outputs, our option, and in the middle we have the geometry. So we can spin around the geometry, we can check, and we can see how our variables are impacting in real time the geometry. So we can change, we can choose different scenarios, we can select our inputs, and when we are happy, we can push, and we can see which is the direct impact on the 3D environment. So in this case, it was just the color of the blinds because we didn't have shadings, but you will see in the next example. But the real powerful of the tool is the explore mode, because this is not very helpful to see 3,000 options, but what we can do is actually compare the performances of all the variables. So we have this parallel diagram chart where we have all the inputs and all the output that we said at the beginning, and the values that every variable has. So we can actually sit with a team in a meeting, and each discipline can decide which are the variables that are important. So in this case, we set it a 45 kilowatt hours per meter square target for the energy consumption. We had the 60 watt meter square for the peak cooling load. These are coming from the MEP team, so we can set it, and you can see that some options are graying out. So that means they're not meeting the targets. And then we can continue after we set the technical requirements with the design requirements. So we sit again with the architect and the client, and we understand which are the variables that are important. For example, in this case, the window-to-wall ratio was important for the view on the City of London, so they wanted at least 80 to 60%, so we can set it in the model, and we can see which are the other technical parameters that allow us to meet the design intent. So we can see that the number of options is reduced, so once we are happy with all the inputs, we can select a single option, we can go on view, and we can see it back in the 3D space. So we have a direct relationship in between the technical performances and the geometry. But we can also set some pre-computed option, so we can select some cases that we want to compare. So we go into compare mode, and we can see side by side how all of these performances are actually comparing to each other. So you have the diagrams, you have the numbers, and you can understand easily why one is better than the other. So, but as we said, parametric modeling is not about energy, it's not about sustainability, it's about finding a methodology or an algorithm to optimize the design. So in this case, for example, for the campus, we changed completely the inputs that we wanted, or the variables that we wanted to analyze. So we changed from energy to shading depth, from to facade weight, to daylight, to cost, and we also had embodied carbon and operational carbon for sustainability reasons. But as you can see, we used the same platform, that is, again, Arup Inform, but in this case, the geometry was the main focus on the building. We wanted to understand how the shading element were impacting all the other disciplines and the variables. So that is the starting point, the design intent we're starting from. You can see it screen. And then we used, again, the explore mode to see how the baseline was performing compared to the other input and output. So you can see in the black line the performances that design intent is meeting, and what we can start playing when we see all the input and the outputs is how can we improve the design. So we can say, for example, now you can't appreciate maybe the numbers, but here we can say we want a cost that is below, I don't know, 1,300 dirham per meter square of facades. We want a daylight factor that is at least the same one of the design intent. We have a facade weight that is, I don't know, 1.5 kilonewton per meter square because we want to optimize the structure. And then we can start playing again with embodied carbon, operational carbon, or all the other variables that we set at the beginning. And then we can, once we set it, our technical input and outputs, then we can finally sit again with the design team and choosing the geometrical things. So, for example, for this project, the shadings were important, so we can say for the south elevation, we want at least, I don't know, 1 meter of shading depth, and for the east side, we want 500 millimeter. We set it, and we can see at the bottom the tiles that are meeting all the targets that we set. So we can scroll through them, and you can see that we have on the bottom corner the geometry of the design intent, and if we click on one of the tiles, we can see in real life how this is changing. So this is very powerful because we can see how performance are linked to the geometry of the building with a direct approach. So in a meeting, we can quickly understand if we reduce the cost or if we improve the daylight, what is the impact. So once we are happy and we select it, we can click it, and we can see how it looks in the overall environment. So if we want to summarize, or if I have to imagine how the early stages of the project looks, for me it's like this. It's pure chaos. You don't know anything. You have a lot of variables, you have a lot of options, and nothing has in order. But what we can do with parametric modeling and total design is putting order with all this chaos, and in the end, helping you finding your design. Thank you very much.
Thank you. Thank you.
The networking break. Let's continue with session 2. Our first speaker is Celeste Gariando, Technical Director at Meinhardt Façade Technology. Please join me in welcoming Celeste to present same material, different physics, structural behavior across extreme scales.
Good afternoon, ladies and gentlemen. I hope you're all doing well. Assalamu alaikum as well. My name is Celeste Gariando for Meinhardt Façade Technology. We are a facade engineering and facade consultancy firm. We are locally based here in Dubai. It's always a privilege to be here and to share with you insights from 2 very different projects our facade engineering team here in Dubai has worked on over the past few years. One is a low-rise waterfront development that has successfully been delivered in the Kingdom of Saudi Arabia. The other is a super high-rise building situated here in Dubai, soon to be recognized as the future second tallest building in the world. Also, I'd like to see familiar faces and also fellow colleagues, many of whom we've had the opportunity to collaborate with in many of our projects we have done here in the UAE, in the Middle East, also here in the Central Asia region. I'd also like to extend our appreciation to the Zak organizers for inviting us again to represent Meinhardt Façade in this conference. Today, I'd like to present 2 very different projects that I would say sit at completely opposite end of the scale. On the left is Amala Triple Bay Yacht Club located in Yanbu, KSA. On the right is a Burj Zizi situated here in Dubai. You know, at first glance, I know they have very little in common. One is a low-rise building, and the other rises to 725 to 750 meters above ground. Yeah, you know, in both cases, we are designing glass and aluminum facades. With the Mala Triple Bay, where obviously, as you can see, The movement in here is not driven by its building height. The facades in this building are responding primarily due to the complexity of its geometry rather than the global structural drift. I think one of the most important lessons that I've learned in Amala is that the movement in this building is often less visible, but I would say it is locally very aggressive, especially at the connections and transitions of each facade system. Comparing that with the bridge is easy, where you can see that the facade behavior is governed by structural lead-induced motions such as accelerations, interstory drift, to name a few. Although the facade system in the bridge is easy is highly repetitive, the movement lies in cumulative tolerances driven by structural behavior because of its extreme height. Today, I'd like to begin with the facade engineering movement report of what is set to become our future second tallest building in the world. Meinhardt Facade Technology has been tasked in providing facade engineering, facade access and maintenance design, working alongside AE7 architects for this landmark project, the Bridge Azizi, for Azizi development. I think Matthew, find out if AE7 is here, the brain behind this brilliant project. Hello, Matt. You know, this is a true super high-rise building. I would say that we are dealing with a lot of things. We are dealing with global drift, interstory displacement, I would say. We are also dealing with human comfort criteria driven by acceleration rather than the architectural form alone. The facade system for this project may be highly repetitive, but I would say that the challenge lies in managing movement accumulation against accumulation over its extreme height. In Meinhardt Facade Technology's vast experience in facade engineering super tall towers such as Bridge Azizi, I can say by experience, and you would agree, that repetition is generally a risk management strategy for movement, for tolerances, and for the performance of the entire facade system. The primary system for this project is a unitized curtain wall system, forming the dominant envelope of the tower over hundreds and hundreds of stories, I would say. Intermittently, as you can see, the base system is interrupted by balcony zones, mechanical floors, each introducing a change in loading demand, each introducing a change as well in the facade access strategy as well. The Bridge Azizi adopts a fully unitized curtain wall system using a pin and roller support strategy, where I would assume that most of our facade engineers sitting in here should be very familiar with already. The pin support provides restraint in one direction while establishing positional stability, while the roller support allows controlled movement in what we call the remaining degrees of freedom. In addition, as you can see in the facade system, the glazed facades incorporates T-shaped panels with integrated glass fins. The T-shaped panels in here are framed using a hybrid system, which obviously allows the glass fin to resist higher lateral loads, whilst they're remaining compatible with the movement behavior of the surrounding unitized curtain wall system of the entire tower. And the next few slides that I'm going to show is a very high-level facade engineering check that I did personally before I come here. The glass and frame, which confirms that the unitized system performs well within the allowable limits, first and foremost, under wind and seismic, of course. For the T-shaped panels, you may notice that the deflection magnitude are particularly already very low, obviously reflecting the increased stiffness that is being provided by the external glass fin geometry. This may sound very colorful, but this very high-level check only means that the facade design is not governed by the unitized curtain wall strength, but instead the facade design is generally being governed by the movement and its long-term serviceability. On this slide, again, is a very high-level engineering check where you can see under the dead load only, the frame, the calculated frame deflection is less than 0.8 mm. You know, this 1 mm, less than 1 mm, meaning that the frame is already very stiff enough without potential long-term sagging or what we call alignment issues, potentially during installation stages. I can say from experience that this is particularly very important, I would say, especially for the T-shaped panels, where permanent deflection could result in visual distortion or uneven load distribution, as what the facade engineers always say. Under the combined wind and seismic, the frame deflection only deflects less than 11 mm. In here, you will notice that the deflective shape shown in here is very well distributed, which confirms that the frame behaves elastically as what we expect them to be. At a super high-rise building like the bridge, I would say stack joint design is driven by accumulation of multiple independent movements, all of which must be accommodated simultaneously coming from the global building movement. I think what's important is that 2 points for the stack joint, the critical points for the stack joint is that firstly, it requires to maintain weather tightness and also accommodate movement all at the same time. On the next 2 slides that I'm going to show is a general overview on how horizontal joints are being accumulated from the global building movement or how it is being engineered. Horizontal joints are governed by many things. It's governed by differential slab movement, interstory drift, column shortening, thermal effects, to name a few. From my experience, most importantly, horizontal joints are governed by interstory drift, which causes the panels to rotate and lift relative to one another. Due to the variations in slab deflection and column shortening, obviously, adjacent floor slab do not move uniformly. And because of that, this results in relative displacement between the upper and the lower panel of the unitized curtain wall system. Of course, actual shortening and lateral movement of columns also results in an additional horizontal displacement, in which for this project, the bridge is easy, has been calculated to be less than 5 mm. On the next 2 slides is another general overview, but this time how vertical joints are being accumulated from the global building movement or how it is being engineered. Differential movement from the slab deflection, column shortening, causes the vertical joint to open at one location while closing at another, introducing, everyone is familiar with, a combined shear and rotation demand on the vertical joint itself. In addition, of course, axial shortening and lateral movement of the main structural column also results in an additional vertical joint movement, in which for this project, the bridge is easy, has been calculated to be less than 4 mm. You know, I would say from experience that although the vertical joints are generally smaller than those of the horizontal joints, I would say from experience that they are generally more sensitive to differential behavior. And I would say they require further attention to avoid binding of split mullions, overcompression of gaskets, or worse, direct load transfer into the glass, which all of the facade engineers are trying to avoid anyway. In a super tall tower, such as the bridge is easy, as you have seen in my slide earlier, facade engineering is defined by movement that is global, cumulative, and fundamentally structural-led. Against the backdrop of Bridge is Easy, I will now introduce a very different project where the building is low-rise, the geometry is very fluid, and localized behavior rather than structural movement becomes the dominant driver for our facade engineering. I'll now move to this project we call Amala Triple Bay Yacht Club, located in Yambu, KSA. Our client and developer in here is Red Sea Global and Amala. D1 architects and engineers are the lead engineers, the architect of record, and the main consultant, with HKS in the UK as the concept design architect. MFT here in Dubai is responsible for the facade engineering and facade access and maintenance design as well. Sorry. On these two images of the building on site, you may notice that while the building is low-rise, it is architecturally very expressive, I would say. And from a facade engineering perspective, it presents a very different but equally challenging approach as well. Amala Yacht Club is defined by long spans and extensive interface conditions, I would say, unlike a super tall tower like the Burj Azizi. The movement in this building is not driven, obviously, by its building height. It is driven generally by thermal expansion or geometric articulation due to its design intent. Amala Triple Bay Yacht Club is made up of a lot of distinct facade systems, each responding to a specific geometric condition. The dominant visual elements of this building are the continuous roof canopies and continuous horizontal bands. However, beneath these bands sits the glazed facades, but they sit within a complex three-dimensional geometry. The glazing for this project is a combination of many things. It is a combination of conical, curved, fixed, operable doors, hinged doors, and sliding doors. The coexistence of these multiple geometries, I would say, drives the facade engineering strategy. The fixed conical glazing at upper levels introduces a change in geometry already, where the glass edges are no longer parallel and planned. The operable system, such as the sliding doors, demands two things. It demands parallel head and seal condition. It also demands controlled movement paths, which I would say as an engineer is already conflicting with a free-form geometry strategy. In these images from the architects, you can see that our facade is neither vertical nor orthogonal. It integrates a tilt, plan and curvature. It also integrates a variable radii. The facades are effectively transitioning continuously between flat, between inclined, and double curved geometries along its entire facade length. To rationalize the geometry, we studied two main panel configurations with the design team. We studied parallelogram and trapezoidal panels. Parallelogram panels obviously favor structural and manufacturing simplicity only for the fixed glazing. However, trapezoidal panels favors operability, I would say, and ease of interface resolution for the operable doors or sliding doors. The trapezoidal configuration was then selected as the final solution during the design intent. The trade-off is very obvious. It's non-repetition. Each panel is geometrically unique, increasing fabrication complexity, also increasing quality control demands in terms of fabrication and during installation stages. The glazed facades, you may notice, are not a conventional planar curtain wall. In fact, the architectural curvature is controlled by a minimum radius of 4 meters, which I would say personally is already sitting at a threshold of Colvin visibility versus a true curved glass. As the geometry transitions from fixed glazing into operable doors, zones, the complexity also increases. You know, geometrically, these doors are straight, trapezoidal in shape, and are inclined in two directions. They are inclined 15 degrees in plane and 22 degrees out of plane. During the design stage, our client, Red Sea Global, requested case studies for a minimal sliding doors of this type of configuration. However, due to the geometrical uniqueness of this door, there are no direct comparable project references available during that time. And because of that, our supplier in Switzerland has committed to a dedicated research and development process only for the sliding door of this project. The objective of this R&D is very simple. It is to understand how an existing sliding door system designed for vertical application behaves when subjected to a bidirectional inclination in plane and out of plane. What you see in here is the photos of the full-scale mock-up R&D, allowing us to observe three important things of the sliding door. It's number one, its track and its bearing behavior. Number two, its frame deformation under its own self-weight. And I think most importantly, its tolerance sensitivity under its inclined condition in plane and out of plane. Doing this R&D, I would say that this exercise is very critical for me because unlike a vertical sliding door, where gravity is aligned within the bearing system, here the lever arm generated by the inclination introduces horizontal and torsional forces that a straight sliding door was never designed to resist anyway. One of the most significant findings in this R&D relates to the head and base track bearings. Our supplier adopted a bearing system that is well suited for straight doors. However, once inclined in two directions, the bearings are subjected to severe multidirectional forces, leading to local aluminum profile deformation. I would say doing this R&D that, this deformation is obviously not a workmanship issue, but rather this deformation is a system behavior issue driven by induced load eccentricity and driven by the reduced torsional stiffness of the aluminum profile itself. The key takeaway, I would say, from this R&D is that the system is technically achievable, but only within clearly defined geometric limits that were not assumptions, but an outcome of an engineered solution. Before I end my presentation, I would just like to say that these two projects uses fundamentally glazing and aluminum as a facade material. In a tall tower such as the Burj Azizi, the movement is driven mostly by global structural actions. The facades in a high-rise building is required to accommodate movement that is predictable, I would say cyclical, over long periods of time. In a low-rise building such as Amala Triple Bay, I would say the challenge is the opposite. Our R&D has demonstrated that, for such a geometry, movement is small, but is far more destructive in nature, where you have seen that the inclined glazing introduces continuous dead load vectors and torsional profiles that a straight sliding door is never designed to resist anyway. Finally, I would just like to end that whether designing a very high-rise tower, second tallest tower in the world, or a low-rise pavilion, facade engineering is more about understanding where the movement comes from, how it accumulates, and designing the facade system that responds, but do not directly react to physics, meaning identical materials, but radically different load path. I guess that's the end of my presentation. I hope I didn't bore you as much. Thank you all for your patience, and I wish you all a good afternoon.
Thank you, Celeste. Next, we explore an innovative advancement in facade materials and self-cleaning technology. Please welcome Fan Lee, founder of Anometal Aluminum.
Okay, today I will introduce one of the kind, the very niche technology, very on the top, is self-cleaning, which works 25 years maintenance-free for facade usage. So owners, if have our material to make this particular material make the facade, don't need to ever clean the building. Anometal is a pioneer and leader of a pre-anodizing industry, specialized in self-cleaning and outdoor colors. Pure Wall, it's called a solar forever technology because the cleaning requires energy from the solar, so it's a solar forever. Most importantly, it says it is uncoated. This is not a coating system. No layer, no lacquer, no painting, nothing. Just chemical, just electrical chemical generate a very hard layers from the aluminum body itself. So nothing applied from the outside. As building are designed to be more and more complex, how to deal with the following cleaning challenge. We provide this project about 9 years ago. This is a museum, 50,000 square meters of anodized aluminum facade. Today can be very dirty. It's a very challenge, very eye-catching design, but cleaning, maintenance is a challenge. I'll show you a video. This is a conventional anodized, regular anodized. This is a self-cleaning. First of all, we put the oil on it. To destroy the surface's hydrophilics. It's a special self-cleaning anodized aluminum. Now the surface has the water because superhydrophilic effect is disrupted. It's destroyed. Not destroyed, but disrupted. Apply methyl red. It's also contamination indicator. It's a red color. The methyl red, you see it's a red with oil, also with oil. You see this is a hydrophobic, not hydrophilic. This is hydrophobic, this is a hydrophobic. Put in the UV chamber. This is imitation of sunlight. After 1 hour's UV light, the methyl red all gone. The methyl red molecules has been decomposed, which means the pollutant or the dirt is being contaminated, has been decomposed. So the oil is decomposed and the superhydrophilic effect is restored. You see, it come back because oil has gone, red is gone. Pure Max treated. So afterwards, when the rain stops, this is like an imitation of the rain stops, no droplets on the surface. No droplets on the surface left. Okay, the Pure Max can permanently eliminate facade sagging stain, pollutant caused by leakage of black organic sealant. This is organic sealant. It performs two ways of achieve long-time self-cleaning. Long-time self-cleaning has two technology. First is photocatalytic, requires sun. Utilizing the natural sunlight to decompose organic matter. Also has antibacterial function, no self-consuming, which means it lasts very, very long, almost like 25 to 35 years. Long-lasting effect. The second function is the superhydrophilicity. It's reduce the surface tension, which enhance the rainwater absorption. When rainwater wets and loosens the dust, the impact force will wash the dust away. Effect is also long-lasting. The oxide layer decomposes the pollutant into carbon dioxide and the water by photocatalytic activity, providing a self-cleaning effect over 25 years. Pure Wall Max draw on the merit for various methods to R&D the most optimized solution. Anometal developed a unique method which forms a single-phase titanium crystal oxide on the surface of aluminum, mixture with aluminum oxide. So the layer, the anodized layer, has a mixture of titanium oxide and the aluminum oxide, inventing a purely inorganic, so that's no coating. Any coating has organic matters, which will result to self-destruction. So inventing a purely inorganic, self-cleaning oxide layer with self-cleaning effect over 25 years. When exposed to the sunlight, the titanium dioxide will release electrons, released. And form electron holes, this is a hole, this is a little hole, which will react respectively with oxygen and water to generate a single oxygen atom, and the hydroxyl with strong decomposition and oxidation capabilities. Those two will decompose organic pollutants that break the links between molecules on the pollutants on the surface of the layer into carbon dioxide, which is air. It's a gas, and the water will steam away. And if there's any water left, water can easily permeate underneath the residual ash, which is non-organic ash, and lift it off in the water. Also, titanium single crystal has super hydrophilic with super wetting properties. Water will lay on the surface as a flat film rather than in form of droplets. There's no droplets, like you see the video. So that stain can be further washed away by rainwater. This is a test, which we in a third-party lab. So this is a red color after 24 hours UV radiation burning. It come back to the color and the oil all gone. So it's delta color delta is less than 3. Standard is less than 3. Our result is only 1.15, 1.3 pieces. So way better than standard. This is our super residual pollutant ash will be washed away from the super hydrophilic surface. So this is super hydrophilic. Water contact angle. WCA means water contact angle. This is the water contact angle, the flat water on it. This is the little angle. Water contact angle less than 10 degrees considered to be called a super hydrophilic. Water contact angle less than 60 degrees considered to be hydrophilic. So this is hydrophilic, has certain level of self-cleaning. But once it reaches the super hydrophilic, this is a 1 level higher self-cleaning from the rainwater cleaning. So this is our test report, 8.9 degrees. So the water drops on the surface real flat. We have a booth there outside. You can see the real thing. So the technology that combines 2 powerful self-cleaning features. The first power technology is inorganic, non-coated oxide layer, constantly decompose the pollutants by utilizing the photocatalytic activity, providing a self-cleaning effect over 25 years. And the residual, which is non-organic ash, pollutants can be washed away from the super hydrophilic surface by rain. This is our color. Every color I'm putting here is outdoor, UV stable. Interior color has unlimited choice. I'm not going to talk about it. So this is only for outdoor. Color will not fade over years and years, decades. This is gray. This is white. It has a little bit rainbow effect. So some kind of golden touch will moving from this side to the other side. So we call it rainbow white. This aged brass, which is very elegant. This is warm copper. It looks like a copper, but not so red, because we add some yellow in it, so it's warm copper. This is copper, very red, true copper. Actually, it's inside the aluminum layer. It has a true copper molecule and a copper oxide. This is bronze, traditional, very traditional color for anodizing industry, bronze. Okay, thank you. Can I go back to see the screen, the movie, the short movie? Because it's so fast. I want people to see no droplets. Okay, thank you. Oh, sorry. Yes. Can it go? It's not moving. You see, this is self-cleaning. See, the water on it is a thin layer. It's a shield. So this is regular anodized. You have many, after raining, this is rain. Yes. We put the oil to contaminate the surface, destroy the hydrophilic effect. See, we put the oil on the surface. It looks like so it's pollutant, air pollutant with the diesel engine gas or gas engine gas. So and then put the red on it. I want to stop it in the last second. Methyl red is also another indication mixed with oil. Indication of the thirds. You can see it's hydrophobic, the same like a regular anodized. That's a UV chamber. UV chamber is Assume it's the sun burning about a week. Can I call stop and you stop there? Wait. No. I'm sorry. Can you fasten a little bit? The last 5 seconds. Last 5 seconds. Yeah, stop right there. See, stop. When the rain stops, conventional anodized aluminum, you have droplets, and those droplets will dry out after sunshine. Then you have gray, dirty spots on it. And this one, you see, the water is a very thin shield because of the superhydrophilics. Goes away, so it's a very clean facade. Okay, that's a true result. You can see outside, we have this machine right on our booth. Thank you.
Thank you. We now move to our special keynote presentation. Please welcome Tony Abi Jibrail, Managing Partner at MZ Architects, presenting From Nature to Immersive Architecture.
Hi. Thank you for coming. I'm an architect, so I'm not going to talk about details or chemistry or self-cleaning or nothing. So this will be for the engineers, facade consultants. I think they gave us very good ideas about what challenges they have when they design a facade, when they solve a facade. I'm going to talk about what challenges we have as architects. This project that I'm talking about is the Team Lab Phenomena. It's located on Saadiyat Culture District. Who doesn't know Saadiyat Culture District? This is the area where Abu Dhabi government wanted to have 6 iconic projects. One of them is, of course, the Louvre, the Guggenheim Museum, Sheikh Zayed Museum, Abrahamic House, Natural History Museum, and of course, Team Lab Phenomena. Team Lab Phenomena is about immersive art. It's a Japanese artists, a company of artists. They've done immersive art. I think who didn't see the project or who didn't visit the museum, I encourage them to visit it. It's really nice experience. It's inspired from nature, but they mesmerize you with their arts. However, one of the challenges in this project, we had to design it during COVID. So COVID started, the pandemic's there, we couldn't leave the offices, and then we had to deal with a team of artists in Japan. They are 6 hours ahead of us. We had a team of developers in Abu Dhabi, but we cannot sit together. And our team, everybody working, some are working from home and some are working in the office. So this was the first challenge. Takuya wakes up in the morning and he has an idea in mind. What is that idea? He wants to change one of the experiences from being a 10 by 10 to maybe 20 by 20. So all the functions are on a daily basis being adjusted and experiences being explored at the same time. So they were trying to do experiences specifically for Abu Dhabi, while we are trying to fix the architecture. We had to develop, so we had the decision taken to free the envelope from the plans, from the layouts. Because, as I said, the layouts have been changing on a daily basis, maybe on an hourly basis. So I don't know if they had a good night, they wake up and have a different idea the second day, so we had to comply with it. So as you've seen, we have the functions below and we had the envelope on top. So how can we design an envelope for such important artists or the art collection that they have? They have about 17 art experiences on 17,000 square meters. The layouts were varying on a daily basis. Even the heights were not defined. So we had to come up with an idea, and we wanted also, actually one of the challenges that we wanted is, because there's a promenade here on the canal, that wanted to invite people to go from this side also, and in the beginning we wanted them to explore the roof, because that becomes the 5th facade that you can walk on and basically experience that as well. So we had the challenge, of course, to have the entrance, another entrance from here to a terrace, and then we have the entrances from here and the parking from this side. So we decided to look at something in common between the immersive arts that they are doing and what we can do together to build this facade. So we had to do something that can reply to the sizes of, for example, this is one of the first experiences that you see, and you see the height is different than the other one, the aquatic experiences, and then you have the sphere, which is another experience. So they are different in levels, and even the floors are different in levels as well. So we thought that we need to design something based on immersive. How can we do something changing? Is it the building itself that changed? It's impossible. So we had to create something that people will see, they recognize, but they cannot identify the details of it, like saying, oh, I've seen this before, so this is the same detail here and there and there. So we had to look at their experiences. This is the cloud, which is basically you come to a space and you can see the cloud formation. You have the rainfall, digital rainfall, one of their experiences. You have the vortex, which is based on the wind and the power of the wind. The balloons, they form different shapes. So we took the elements that affects the environment that we're in. Basically, with the wind, we can see the cloud has changed. We can recognize it's a cloud, but we cannot say, oh, I saw that cloud last week. We cannot say that. Or the waves, you can say, oh, that's the same wave that happened 2 minutes ago. You can see it's a wave, but we cannot identify it as a wave. Even the dunes, sometimes people get lost in the dunes at the desert because they repair themselves to a dune which has moved due to the wind. And of course, the mist and the fogs that changed. We took all these elements together and we tried to mimic an architecture that when you're walking around this architecture, you feel it change, even with the light, with the shadow, and makes it more organic. So the architecture is covering the experiences. The envelope is covering the experiences. At the same time, it is immersive by itself because this building, you'll be able to see it from a bridge, from top, crossing from Abu Dhabi city to Saadiyat city. So you see the first one on the left side, if you're crossing from Abu Dhabi to the other side. You have the experience of seeing the roof. And then in different daytime, you can see the lights and shadow playing on that roof. And on the facade as well, you can see different details as you walk from one side. If you walk from this side, is different when you walk from the other side. You can see the pictures later on. So this was the first renders. Of course, the interior has to follow. So we thought about something organic. We wanted something to be more fluid. We had the concept like, okay, you've seen the earth from outside. What if we go inside the earth? What you're going to see the cavities, how it will look like. So we tried even to make the interior in a way where you have those kind of beams and columns are connected together to create the spaces. And actually, this became one of the spaces when you walk in the corridors of that building. So from the first sketches, we designed something that it's not like normal building where you have the four facade, you have the one detail that is repetitive. We had to design something that every facade is different than the other. So we started with hand sketches. Of course, we did some models, first models. We've done the digital model then. Of course, parametric model to see the sizes of the panels. Ideally, we didn't want to see any grooves because grooves, they don't appear in any geometry or in nature. So it was a challenge for us to try to maximize the size of the panels. And here we're talking about panels 6 by 6 meters. And then every panel is different. So that became a problem to the engineers and the facade consultant, and obviously the cost went up. We tried with the engineering to stabilize the structure of the facade. So we had layers of the structure, steel structure below the facade and the layers above. And that becomes the skin. We integrated some of the functions from inside, like here they have the T space, they call the T space, which is an experience by Team Lab. And we extended the water from inside to the outside and became a water feature outside as well on the promenade. These are the composition of the layers, and this is how it ended up. So as you can see here, the facade is different than the other one. The other one is more inviting up to the roof. This way you can see the building is changing from side to side. Here it's higher, then here it's lower, and then you go to the other side, it's different. And then you can see the sunlight, how it works on the facade with changing colors and changing, the shadows and the light with it. That's from a different angle. So you see, before I showed you a picture just from here, and you've seen the cavity on top. Here now you see the cavity is below, so you can see difference in level, and that's the water feature that I was talking about from the water inside the building. Again, this is the entrance. This is from top. It was very challenging, not only for us, of course, the facade consultant and the contractors to build this building with more than 3,000 panels. Every one is different than the other. And that basically raises now the question of future design. How can we make this kind of building? Of course, we're talking here about the condition, weather condition. We talked about several materials, options of several materials. GFRC was the one we selected because of durability, of course, the weight and the free deformation and the fire safety, color stability. All those items pushed us to select the GFRC. We had designed the structure. They have the primary structure, secondary steel, and the tertiary to hold the system. And then we put inside the inner water because of the grooves. We didn't want to have closed groove, and we prefer to have the inner weather line below the GRC line. So of course, starting from scratch, we used 3D Max at that time. Rhino later with BIM and panelization and fabrication, then installation. So we have like I said before, because of this weird shape or organic shape, we had to have every panel with a different size. As you can see here, even the grooves were trying to follow the shape because of the size of the panels that we had to. It was, like I said, like you see here, it's a different panel with a different kind of transformation just to follow the line of the waterfall. Of course, now what the idea behind this, why I'm showing this project as a case study, because we need to, together as architects and suppliers, scientists, contractors, to find a way how we can make such architecture easier. It is not straightforward. We've seen talks about the self-cleaning, like just before we saw a challenge with the sliding door, glass, two-side sliding. Yes, of course, that's a big challenge. Meinhardt, they've done very good work. Here we are looking for something where we can have mass production faster with a low cost, because the time obviously is the essence. When every time we want to produce a panel like this, we have to make a mold. Then this panel, we have to make a different mold for it. And that is the time to make these two molds and cast them and wait for them to dry and bring them to site and install them. That takes a lot of time. So I encourage contractors, manufacturers to find a way where we can do organic shapes with a faster way of installation and even bigger size, because again, what the target was to make as big as possible the panels. And you can see here, this is a 6x4 maybe. Because of the joints, we had to make this kind of design. Am I moving too fast? So we need to let the geometry drive the engineering. We encourage, as I said, the engineers to look at the solutions for us, to give us more creativity so we can be more creative and design different things, responding at the challenges from the developer already and with the operator They have a lot of requests, so we need to make sure that we comply with their requests and make something unique. But later on, we need engineers to follow. We need collaboration. We need prototype, if we can build prototypes and try to do some tests to make sure that we are complying. So now, as I said, things like parametric, I think our colleagues from Arup talked about parametric and engineering before they designed the facade. These kind of things that we need to look at for massing customization. We need to look at the performance-driven, like we said about the self-cleaning and stuff like that. We maybe also look at having, in the future, having a digital copy or twin of the facade where we can have sensors reading what's happening on the facade itself, where we can take data and create more solutions. Also maybe use new technologies like 3D printing. How can we use these kind of technologies to do these kind of shapes? Kinetic facade as well might be a solution. This is something that the future we should look at, where the facade lives and becomes nature by itself. So the facade responds to the nature conditions by having those kind of details. These are generated by AI, these images, intentionally to show you that, or to talk about AI, which is the topic of everyone now, that we need maybe to think outside the box and try to create something new. And now this is something that we looked at, like if we can have self-healing facade, maybe with organic materials now, as we can see, inspired from any organic tissue, that we can create something that it is self-healing. We can use also parametric or AI to help us with optimization and maybe create something new. So eventually we want to say that architecture should not imitate nature. Architecture should behave like nature. Thank you.
Thank you, Tony. Our next session examines the mindset behind successful facade projects and why the right thinking often determines project outcomes long before construction begins. Please welcome Osama Abbas, Chief Executive Officer at IBEG Group.
Thank you, Tony, for the enlightening presentation. Okay, today I will be discussing a subject that quietly shapes the success or failure of every facade project. We spend enormous effort discussing design, materials, discussing procurement, testing, as well as construction. Yet, the quality of the facade is determined long before any of these things happen. It is determined by the way we make decisions. Good afternoon. My name is Osama Abbas. I'm the CEO of IBEG Group. And this session is about a perspective into facades, through the lens of systematic thinking, as well as the powerful forces that shape the behavior of building envelopes over decades. So if I ask any one of you in this hall, what's the criteria that must be used in order to assess the technical performance of a facade? I presume that everybody will have a correct answer. From structural performance to acoustic performance, to the U value and the thermal performance, to cleaning and access, all of you will have a very good valid reason for why this is a criteria to basically have the facade succeed. So we can establish that we are not short of expertise. And the challenge is not defining success, it is basically how to arrive there. So we also know all the stakeholders. In addition to the criteria, we know the stakeholders. We know that the developer seeks value, the contractor seeks buildability, the architect seeks vision, the consultant seeks compliance, the engineer seeks performance, and the facility management team, they seek maintainability. So we know who's involved, and we know what do they seek. And the challenge begins when every stakeholder pulls towards his narrative in order to achieve optimization. Now, if we know what makes a facade successful, and at the same time, we know who are the stakeholders and what are they seeking, then why we have projects that win awards, while other projects that end up in disputes, arbitration, and legal claims? And why do intelligent teams still deliver failing facades? The instinct goes towards a bad product, or bad engineering, or even bad workmanship, installation, etc. But we believe that the core is in a disconnected mindset, where each team is thinking in a separate silo. They're not connecting. So every stakeholder is optimizing his end of the story. The architect looks at beauty, engineer looks at performance, contractor looks at the program, and each of the 6 stakeholders, they focus on their own target. But no one hits the facade. So as you can see, the facade basically is a miss. And what the facade receives basically is a stretched version of the optimized scenario. Again, one detail, one fact, but different narratives. So for the same fact, we have different interpretations. The architect wants it to look good. The contractor wants it buildable. While the facade maintenance, they just care about how to access, clean, and maintain it. So the challenge is not the lack of expertise, it's the challenge of alignment. This is a very core slide which talks about local optimization versus global consequence. So if I'm basically optimizing locally for each criteria, how can I achieve global optimization? I'm only receiving global consequence, and I'm not receiving global optimization. So each of the 6 stakeholders, they optimize aesthetics, cost, whether CapEx or OpEx. They optimize program, optimize performance, compliance, and maintainability, whereas all of these are impacted: cost, performance, operation, in different frequencies. And the main question is, who inherits this all? The project finishes, the teams leave, and the building remains. And the owner is the single person who remains holding the project. He remains responsible for the decisions that have been taken by all the stakeholders. Another party who is a part of the owner's team are the FM team, who also have to suffer with the building maintenance, difficult access, continuous and constant inspections in order to know exactly what's wrong with the facade, routine cleaning, and replacement and repair of the building material at the cost of the building image and interruption of work. Not all decisions reveal themselves immediately. Some of them take time. Some of them look brilliant on day one, but after 20 years of construction, they become expensive mistakes. So time does not compromise like what they were doing during the design of the project. Time only reveals the problem. And it's a problem also when we design the facades for today and not also for tomorrow. And when an iconic job on day one becomes another construction site in 5 years' time or in 10 years' time, where the owner has to pay for a higher capex again, higher OpEx, a lot of materials replaced and changed, and at sometimes a sick building syndrome where we don't know actually where the problem is and have to do extensive testing, extensive inspection, and even destructive inspections. So the questions change over the due course and lifetime of the project. An important question today might not be important tomorrow, and vice versa. So during concept, we are asking ourselves, can we create something iconic? And in design, we talk about performance. In construction, we talk about delivery. In handover, we say, does it meet our expectations? But then the real journey begins. Can it be maintained efficiently? Can it be repaired when needed? And would we make the same decision again? And this is something very important that we see in the industry of people and professionals who have done projects, but there is no follow-up later on to basically understand whether the decision made at that point in time was correct or not, whether the owner is suffering or not, whether the FM team is able to actually run very efficiently. From our perspective, great facades balance 3 dimensions. First dimension being people. And here we ask the question, who is involved? Who is affected? So here goes back to the 6 stakeholders and the owner. The second dimension is time, and the question is, when is the decision made? Is it too late to make that decision? And the life cycle, how long will it perform throughout its life cycle? So 1 decision, 3 dimensions, enduring performance. This slide shows, instead of the previous slides where we were showing every party pulling towards their side of the equation, this shows that excellence begins when we understand that the way we make our decisions affect others. So the architect understand that if they go for extreme aesthetics, there could be a limitation in maintenance. There could be limitation in maintainability. There could be limitation in the durability of the detail. And if the contractor only pushes for the timetable, there could be a problem in quality. Again, with the timeline, because it's very important, decisions are made quickly, but the consequences often last decades. So we should not be evaluating our decision at that particular moment, but we should be reflecting on that question later on in the process. Dimension 3 is the life cycle. And the life cycle, as you can see, it's inspect, clean, repair, replace, upgrade, and adapt. So the facade and the building is not a finished product. It's a living asset. It continuously adapts. And the tenants ask for things inside the building. Are they being able to live comfortably? Do we have thermal comfort? Do we have acoustic comfort? Are we able to clean the glass facades on a weekly basis or maybe a monthly basis? Or is it impossible to clean it, so we do it once a year and it remains dirty? How is that reflecting on the ROI of the developer, on the value of the property? So the goal is not simply to build the facade, but the goal is to keep it living as an asset. So the right question at the wrong time is useless. If I'm asking about facade access and maintenance when the design is frozen, then I cannot have any flexibility there. And if I'm asking the question about budget when I finished the design, that's also, not so good for the budget. So the point is, asking the right question is not enough. Timing matters. And know when to ask shapes the outcome. It's not only important to know what to ask, but also important to know when to ask. And we talk also about the sequencing of questions. So we know when to ask, but how do they relate to each other? And in the absence of a destination, of an optimization direction, I'm optimizing in space. So if my aim is to optimize aesthetics or to optimize cost, that should be clear. So before we optimize anything, we must know the destination because it's meaningless. Now I proposed or I showcased a problem. Now I'm going to go through the proposition of how to solve the problem. The sequence. We always start by defining the vision. That's where we start. What are we trying to achieve? What are we trying to design? An iconic building, a cost-effective building, a highly maintainable building. So step 1 is vision. What are we all trying to create? And the key word here is not create, it is all. And all is not the architect. Usually vision is created by the architect, but it's rarely delivered by the architect. I cannot deliver vision if 5 of the 6 stakeholders resisting this vision. They must understand Why is the architect going in that direction? What's his vision? How can I help him achieve that or her achieve that vision? And it boils back to what I was talking about regarding understanding the consequence of my own decision. If I'm the contractor, my job is not to resist the architect only, but to also help him achieve the vision. If I'm the engineer, my job is not only to do compliance certificates, but to also support the architect in his vision. So it's what we are all trying to create rather than what the architect is trying to create. And that's where the whole group of people on the job will help deliver. Point 2, budget. We jump directly into budget, directly. Because whatever the architect he puts on his paper, he jots the line, that's a vision. We should have an estimate of how much that would cost, because the developer needs to have his ROIs. We always find ourselves, at the dead end, detailed design stage submitted, going to tender. At that point in time, they introduce a cost consultant and the contractor comes in. Cost consultant says this will cost 120 million. Contractor pushes in 180 million. What happened? Value engineer, and then there's no value engineering, there's cost engineering. Remove this, put this, do that, whatever. Remove the paint, whatever. Remove the installation. So this is because budget is talked about pretty much later. So the second step is budget and how much it should tentatively cost. The developer must know what he's biting in. Step 3, physics. Physics is all about performance, water tightness, air tightness, thermal performance, acoustic performance, building movement, calculations, you name it, in order to be able to make sure that our facade basically meets the physics requirements. Step 4, buildability. And here it's very good to talk to contractors. I don't believe that the consultants and the architects should be, working day and night on a design that's complicated, that's iconic, without, seeking any kind of guidance from a contractor who has done this before. And who has done this before is very important, guys. Why? If you're having an iconic facade such as the one Tony was now talking about, you need to have a tier A contractor. Don't go talk to small GRC contractors. He had the GRC work. So you need to select your contractor because that will also link to your budget. As we all know, a tier 1 contractor will not come as the same price as a tier 4 contractor. They have different budgets, different ways of thinking. They have engineering teams. They don't only have a facility for fabrication. And that makes the big difference for your project. So buildability is important. Moving from that, we go into operation. Can it be maintained and cleaned? And at what cost? Everything can be maintained and cleaned. The issue is, how long do I have to disrupt my building operation? How long do I have to wait until this facade gets cleaned? Do I need to park near the sidewalk? Is it an easy clean? How much do I need to pay for cranes and people hanging from ropes to maintain one panel or replace one panel? I mean, the no-brainer is, I should not be waiting. It should be an autonomous operation. But I need to check that before completing my design, understanding my cost there. And again, of course, budget again. Because like the first two, they were what? They were vision and they were physics. And I have a budget. The second two are durability and operation. Again, I needed to have a budget. Need to pin down that number. Need to refine that number. Buildability and operation, they are from a contractor point of view. Maybe an FM team on board of the contractors team or part of the FM team that will help actually to understand how much this thing will cost. Point 7, durability. How will it age? Now I'll talk about coatings, PVDF coatings, powder coating, super durable, hyper durable, anodization, hydrophobic, whatever. And life cycle value. We always ask at IBEC, we ask, what's supposed that building to live? What's the design life? 20 years, 25 years, 15 years, and believe me or not, we don't get clear answers. We embark on a job and nobody has a number. After how many years I need to maintain the facade, replace the facade? And these numbers are very important because they will dictate what type of material you are using, impacting cost, and application and selection of contractor. Point number 9 is cost. So out of 9 points, 3 boil down to cost because that's what life is all about. We all know that, right? And we all had our fair share of the tender being out, contractor coming with crazy numbers, developer saying, what's going on? Get me back to my budget. Especially in these days, you know. We cannot get any material supply, everybody is overloaded, so the prices get higher and higher. Bottom line here is the cost is the outcome of all the questions that came before it. A facade is never the result of one decision by one person. It's the result of hundreds of decisions taken by several professionals over the course of the project lifetime. Better facades are not created by asking more questions, but they are created by asking the right questions at the right time. You have one facade, you have one shot for that building. Ask the right questions on time. Thank you so much.
Thank you, Osama. All AIA members are kindly requested to proceed to the exhibit area during session 3 to complete the required form in order to receive your AIA credits. We now arrive at our first panel discussion of the day, Architect plus AI, designing the next generation of facades. Moderating the session is Drew Gilbert, lead design architect and global AI lead OBM International. Joining him are Alina Valcarce, Amir Shurafa, Christine Espinoza Irlanda, Khalid Iskandar, Nick Holmes, Maya Cochrane. Please welcome our distinguished panelists.
Look at the screen. All right, looks like everybody's ready. Thank you all for coming. We have an exciting conversation across the intersection of AI and facades. I would like to start this conversation off by a little bit of background. Over the past 5 years, AI has really made a name for itself. And it seems like every year, there's always something new, something interesting to catch up on. And within the last 2 years, AI has had a massive impact in the way architects, developers, and innovators are working. It almost completely reframes the way we work. And I would also like to make a very clear point that AI is a tool. So you can use it correctly and incorrectly. But at the end of the day, I highly recommend taking the time to research how AI can impact what you do every day, because I've seen a lot of positive impacts. Without further ado, we have our star panel here with all of these very well-known people. And the first conversation topic is going to be AI as a creative partner. Notice how I didn't say designer, creative partner. So many designers, architects across the world, whether they're interior designers, architects, and artists, are using AI tools in the early concept stages. And I'm curious to know how AI has helped expand the way that you guys are exploring facades, ideas, and architectural expressions. And have you discovered forms and ideas that you may not have explored otherwise?
I can start. Well, first, it's a pleasure to be here today and discussing a topic that, I mean, it's in everyone's daily life nowadays. As you mentioned, Andrew, the AI is a very strong disruptive tool, and you need to understand it as a tool. It's the same way that it was disrupted the electricity at that time, even internet at that moment. Now AI is in everyone's life. And the most important thing is to understand how you are going to be using this tool. Again, as you mentioned as well, AI is a booster of anything that you do. So if you have a very bad idea, you will boost that very bad idea. If you have an amazing idea, you will go exponentially of what you can do with that idea. So it is really pushing forward how we think, how we create, but I always believe that it needs to come from you. So coming back to your question where you're mentioning how we use AI, especially in the initial stages, how we design facades, because we are talking about facade today. And I mean, we are really pushing forward and really exploring AI, and it's very important tool in our business nowadays, but always that first ideas come from us. So we understand the size, we really study what are the options to make, what we wanting to achieve here, how we are going to, what is the story that we are going to bring to this project. Then once we have an initial thought, an initial even massing, and even an initial 3Ds that we wanted to explore on the process, then is when we use to boost that. Okay, how much further we can push this initial thought? How much, what we can do? What can materials, change materials very quickly? What elements, small details that we can change here and there, but it is coming from an initial thought. And it's really important that you are able to control that because if you, I mean, AI every day and constantly, and it's, I would not say a fight, but it's something that you need to be very aware, continue committing errors. And you as an architect and the knowledge that you have as an architect, you need to keep understanding where are those errors, where identify them, change them, and keep moving. But it's really, really important that you are able to control and you are able to design with the knowledge that you have.
Absolutely agree. Anyone else have some thoughts?
Hello. Yeah. I'll add in something within your question. So first of all, good afternoon to everyone, and thank you so much for having me. I'm Christina Espinosa Orlando, Associate Director at Godwin Austin Johnson. I'm also an artist and illustrator, and somehow this passion about making things better turned out into a career. And for 2 decades, I've been involved in master planning and architecture within the region in Asia. Going back to the question about AI as being a creative partner or AI as a designer, I would say it's yes, but in a way that's different. I see AI as a very enthusiastic intern, an intern wherein it will pitch out 10,000 options right before I finish my coffee. But at the same time, since me as the senior, as a designer, I would use AI as something that it will pitch out 10,000 options, yes, but as a creative designer, as someone that will scrutinize all those, maybe 90% of those will be usable, 10% will be valuable. So the value that I add in is not about creating the design itself. I wouldn't let that AI to create the design for me. I would always tell my team that it's okay for my team to use AI and whatever tools that I can do. They can maximize the tools, they can use and enhance their productivity and enhance their presentation. However, at the end of the day, we are instilling within our team that AI will be the creative partner as long as it's not designing for us, that we dictate the output of the AI, that we will be the puppet master rather than the puppet itself. That's how we use AI in our office.
That's good. So I'd like to thank everyone for coming. My name is Amir. I'm head of design, the new properties. And regarding the question, I would like to add something that maybe right now we are having a new friend in the industry. This new friend is going to do a lot of shortcuts for us. You know, there's a lot of work that takes time. Whenever you have an idea, you have a creative thought that you want to just visualize it and bring it to life, see how it goes with your design, with your thoughts. This is the tool that we were waiting for a long period of time. Since we, like the architects used to just draw with their hands, then we have a lot of new technologies like softwares and new visual tools. And this is the tool that we started to skip rendering or starting to skip a lot of process during the work to visualize something. This is one of the most important part, and also regarding the process of doing your project. Once you have a creative thought and you wanna bring it to life, instead of doing that, start from the beginning, doing a new workflow and embedding AI in it. So embedding AI in your workflow and during the steps that you're following while designing a project will help you change the way you think, instead of just following one step and other step and other step, then reaching something that needs to be redone or changed. You can shortcut all of these process while just by sketching something and bring it to life. Also by doing research. Nowadays we are having great tools for technical manners, like how things can be done, what materials we can use in this space. So it's not one thing that we can utilize AI with. It's just a new way of thinking. And once you adapt this new way of thinking, you will start be more creative. It's something that is added to the human skills. It's not something that's replacing people. It's just something that gives you a superpower that can change the way you think, your creativity and your adaptation of the changing world, very fast changing. This is what I think about recent changes in AI.
Can you guys hear me? Yeah, there you go. Some lovely pointers right there from the three of you. I'd like to, before I get started, I would love to congratulate Drew for getting nominated as the, what was it, the Tech-Driven Architect of the Year, right? So,
yes, man.
So for those of you who don't know, now you know, Drew has all of these accolades every year. He's very, very tech-driven with AI and does a great job as well. So yeah, congratulations, Drew. A question to all of the audience very quickly. So with a show of hands, how many of you have used any form of AI tools 4 years ago? Show of hands, guys. 4 years ago. How many of you used any sort of AI tool?
3?
Do I have any, no hands?
No hands 4 years ago.
No hands. All right. So now again with a show of hands. Okay, maybe one guy at the back. So again with a show of hands, how many of you have been using any form of AI tools today? Raise them up, raise them up, raise them up, raise them up. Look around, guys.
Everyone.
Look at that. And this is the conversation today. Is that a lot of us think, using AI tools is just going to help us write emails or, respond to some questions or probably tell me more insight about my fitness, which a lot of us are struggling with maybe. But as Mo Jawda says best, who's the ex-CBO of Google X, he's like, Google, AI is being driven in the conversation of figuring out a cure for cancer. It's redefining mathematics. So it's way ahead of us, and it's much bigger than just architecture, design, or even facades. So I promise I'm going to make this a little bit briefer and more concise about facades. But rule of thumb, guys, is that what used to take us 3 weeks to do, now we can do it in 3 hours. Probably less. So to Alina's point, for example, if you're going to insert, or if your input is going to be junk, expect output to be junk. Mo Jawda says the same thing. He goes like, with the let's say the presence of AI and this progressive development that we're seeing today, we could reach a point where we're going to reach a point of utopia, for example. But because we have a lot of evil and there's a lot of junk input, it's not that AI is going to drive us to dystopia. It's just because there's a, not us, obviously, but there's a group of people in the world, let's say, that input is going to drive AI, or AI is going to learn from our data in the wrong way, and therefore our output is going to define that junk in the first place, right? And also to what Amir was saying is that, imagine, like, I used to sketch, 13, 14 years ago, let's say, back in university. I would have never even, I never imagined it, or even would have never crossed my mind that I would actually realize my sketch into a render, let alone put myself inside there and then turn this into an animation. Let alone that animation turns into a storytelling video, a short film that would have costed me probably hundreds of thousands of dollars in filmmaking. And now all of these skills, guys, they are at the disposal of our fingertips. So it's just mind-blowing to see the fact that today I can just step outside. So I live in the JVC area. And to me, like, JVC is like visual pollution. There's a few aesthetically good structures, but I'm like, oh man, my eyes. So I'm like, you know what? I'm gonna make those changes myself. So I snapped a photo of like a few buildings that didn't quite like. Went back to the AI, put them inside, drew a few things on that facade, and asked the AI to change it. In seconds, I can come up with all of these different variations. What could have been? In seconds. I'm not waiting for hours. I'm not even using resources. And on top of all that, we're able to do this at the highest quality. So to me, I think it goes even beyond just as a creative partner with AI, but it's more of like an extended tool that has been so proficient in giving you the capabilities that you never thought you ever had.
Absolutely, and that takes us to our next point. We're not just designing one facade or 10 facades. It's like, what could be the perfect facade, and how do I communicate that to my team in the least amount of time possible? So AI has actually helped us accelerate design exploration, which in the past, let's say you had to do 10 options, it was like a very daunting task, like 10 options, and then by the time you get to the end, you're like, maybe I don't even like them. What if you could do it quicker? So AI is allowing us to explore these many options very quickly. And how do you think this ability is influencing the way you approach design? Specifically, do you feel that AI is helping architects push the boundaries further?
So first of all, thank you very much for having us here. And my perspective on this question is that it's actually helped us a lot, because before I would compare it to the traditional workflow of having a sketch, having to CAD it, having to 3D model it, and then render it. Already you've got a full process that takes over a week. And now, with the use of AI tools, we've actually been able to cut this down into a much, much faster process. And best way I can see it, as well as what everyone else has been saying, as AI being a creative partner and not over replacing designers and all of this, is that now you can cut down this process into CADing, sketching, modeling, perhaps in one day, and then the next day we have a full day for AI, which gives us hundreds of options. Now from this hundreds of options, it's almost like you have a waterfall of ideas where you're generating one image, for example, and then from this, it gives you another idea. So from the result, you see, I like this specific element, and now you can adapt it and build on that. So essentially, you almost have to manually shut off this tap of creativity because it continuously gives you ideas.
I want to touch on both of those points. So first off, my name is Maya. I, 4 years ago, was playing around with AI and image creation. And I think what is interesting is, like you've said, we're actually at the dawn of a new revolution. This is the equivalent of the Industrial Revolution or the .com. And I want to take us back to it not necessarily being about multiple options, but an ability to amplify our intelligence. And in the end, we still need to be incredibly discerning about what that really means. And I think the future of what we need for AI is not that it looks like this or we can adjust it like that, but ultimately when we come back to the facades, is this going to perform better? Is this going to relate climatically? Can we look at this in a really deeply intelligent way so that we know in the future, we can estimate what the impacts of what we're building now can be? I think this is the step that we can begin to look at with AI, that it's an intelligence amplifier, and it allows us to ask those really hard questions so that when we have this variety, we can have intelligent decision-making around it.
I would like to also add on your point that whatever we are seeing right now is just the first step of AI. Like, we are just starting AI. Like 4 years ago, we didn't have nothing. Like, all of us, we tried with DALI and this new, very old technologies to get very rough ideas of what we are doing. But what I'm saying is, right now, we have, to be honest, nothing of the capability of AI that we are going to see the next 5 years or 10 years. And this is not something easy to understand, because none of us right now understands the capability of AI and what's going to change in the industry or all the industries. Because, for example, the way we build buildings, the way we design, the way we use materials, the materials itself, because once you have the design in the digital world, you need to bring it to a real world, correct? And this is the real challenge for all the architects and all of the industries, not only the architecture industry, because we are connected to all of the other industries. So this is something that needs to be really highlighted, because once you have the mindset of changing and rapid changing, very fast changing, so adapting new materials, adapting new building ways, adapting a new way of thinking, this is the people that will success in the new future and the coming future. Because once you have this mentality and this mindset, you will be at least doing your daily research and doing your daily trial and error on the new tools to train your mind to adapt what's new in the market, because it's a training process. You cannot jump in the middle of AI era and say, I want to be one of the best architects or one of the best people who are doing a great job in the industry. You need to train yourself not in the architectural techniques only. You need to train yourself in the research techniques, in the AI techniques, and in the new materials, a new way of thinking. This is a new way of thinking era, and everyone should adapt it.
You know what's cool about what you said, Amir, is that I'm going to answer this question on behalf of all of you guys, including the panelists. Excuse me. Guys, what happens when your clients start generating AI images on your behalf?
Yeah.
We have that experience. Yeah.
I didn't say it. Right? Imagine they come, you have that brief of facade changes and so on, and they come in the room, and that's obviously happening right now, as Christine is saying. I want this. You look at that image, and it's just, by the way, it's the same conversation, right? When your clients used to come in the room as well, and they show you images from Pinterest. I want this and that, and they have nothing to do with each other, right? It's the same set of conversations. But now it's even more progressive, because the clients are not stupid. They're intelligent people as well, most of them. So they're going to be able to generate, the same set of images that you are generating. But what will differentiate you from your clients or the rest of the market, from your competitors, let's say, is what Maya was saying. That taste, that eye of discernment. So that what comes before the prompting, what comes before, I want to generate 20 images. Everything that Amir was touching on right now. The things that actually matter, right? So just to conclude, is that we have a responsibility right now in terms of everyone in the room to lead by example. And how do you do that? You got to educate yourself. Unfortunately, you got to spend more time figuring out these tools, take workshops, master classes, whatever it is, and understand which tools to use in that specific workflow. Otherwise, you're just going to go back to ChatGPT, show me 10 variations of this facade. and then you'll have like the same set of images that everybody else is doing, you know? That bronze, gold-looking images, and which your clients probably can do even better. Correct me if I'm wrong.
Absolutely. I wanted to add something on that. When you mentioned about the client experience, yes, we had that. There was a chairman that came to us and asked us to develop a luxury residential with a full AI image as a client brief. And true enough, yeah, I call this Instagram architecture. Why? Because it's like for 3 seconds, yes, it's nice, it's visually, it's shimmery, it's nice, the mood is there. However, when you scrutinize it, you would understand that it's not buildable. The building itself was high-rise, but you have 12 meters deep balconies. Even when we speak to the structural engineers, they would say this would be impossible to build. Yeah, maybe, but at a certain cost. So we came back to the client and told them, okay, we've tested the brief that you've given us, and is this really what you want? If you really want this, this is what you get. I think as architects, it's not as if we're changing our profession because a new tool just came in. It's about us asking the right questions, and knowing the due diligence we have to do right after we receive the AI image. Every prompt, every generated images, 10,000, maybe hundreds or more, we can prompt that, and everyone can do that now. But it's the skill, the technical skill that we have, the experience that we have, and also that's why we have to do our due diligence and question if it's really buildable. So my point now is that as architects, we are not, in our profession, yes, since everyone here is using AI, the difference that we can add in is not to generate more and more images. The difference is that we are able to decide, and we can make that executive decision based on our experiences, our technical skills, and we decide what gets built and what gets to be built. And we can advise that to our clients and educate our clients to say that, hey, whatever you have decided on, this is the right way. And that is what we are hired for. We're hired to serve and to solve problems and to be creative, adding in the technical expertise to that.
And that leads me to a very interesting question that pertains to Nick and Khaled mostly. AI is a fairly general tool. You can make text, images, videos. I mean, it just keeps expanding, 3D models. I mean, at some point, it's going to touch everything. And it's not a tool that comes with an instruction manual, in my opinion. Yes, you're writing prompts most of the time. Anyone can do it. But in my opinion, there are people who are driving how we're using AI in our firms. And I think it's very critical that, for example, if you have a BIM strategy, you should also have an AI strategy. And so the question to you, Nick, is, since you are a lead AI innovator in your firm across multiple offices, how important do you think it is to make sure that AI is being used correctly?
It's a very good question that a lot of people overlook, actually. And for me personally, and from my own experience, it really comes down to masterclasses and workshops, especially internally. So, for example, I'm biased, obviously, but I believe that every company should have someone that is solely dedicated in working on AI. Not necessarily project work, but someone that is there to be able to research and develop, as well as host, as well as upskill everyone internally. And of course, be able to step into project work as and when needed for perhaps something that would take more time with AI, whilst all the other designers need to focus on non-AI related tasks. So the answer to your question, I think, is basically to make sure that everyone is on the same page and to keep a very structured schedule of workshops, as well as making sure, like, as soon as there is a new tool or a new workflow that you've found out, to write it down, test it, and the opposite of being structured, which is to be playful with it first. That is very important as well, because at the end of the day, it's like a playground to me. I love to play around with AI and take it as seriously and non-seriously as possible, just to really see how far you can take it, where you can find it most useful and not useful, and then from there, be able to implement it across the board to everyone else.
Completely agree. Khaled, do you have any additional takes on this as you're an AI educator?
I mean, Nick kind of knitted it very well, but if I were to add anything onto that, it's that I think we're always like trying to, speed things up and go way ahead of ourselves, as Maya was saying just a few minutes ago. Guys, this is still an ongoing revolution. And also something that Amir mentioned in the very beginning. This is the worst that it can be today. The worst. So can you imagine what's coming? And my 2 cents on that is, we are always very driven on, all right, what's the ROI on this project? How can we make this effective? How can we make this faster? How can we make this more creative? And then we forget our people. We forget our team members. At the end of the day, I'm human, same way that you guys as well. Same way your team members are human, right? Some people have insecurities. Some people are misinformed. Some people are still like, they're intimidated by these tools. They have that kind of fear. So how do you take your team members from fear to fluency? Because if you're always counting on AI to drive your projects, to just drive, revenue, your team members are gonna, slack, or they're gonna be feeling very intimidated, and they're gonna feel like lacking, or, being late and behind. As opposed to empowering your team members of what are the possibilities and what is the potential of these tools in your own workflows. So again, the investment should be more about, in your own people and how to kind of go from fear to fluency on your team members. This is your investment. It's not only just the AI tools. Because as business owners, you definitely don't have the time to sit down and R&D with these tools. Nick knows. And the rest of the gentlemen and the ladies know as well. There's no time.
Can I comment on that and then get your opinion? Because you're talking about workflows and you're also talking about writing it down. Every 6 months, there's a major upgrade. And we throw everything we thought we knew and we were doing out the window because we go, oh my gosh, this tool just got better. And when we had our little private conversation before, you were talking about, at the moment, the limitation is that it's working off of pixels.
Yep.
And the minute we start giving it dimensions, like what we see in our Revit models, X, Y, Z, gravity, when we can build in some of these other elements, it's going to take it to the next level. But efficiency and workflow without care and real understanding and projection for the impact of the future isn't intelligence. So I want to kind of ask that of, you guys who are delivering things, using the workflow to help you deliver better buildings, how that's kind of feeding back into your systems.
I just wanted to add, Maya, I'm going to go a little bit back and then back to you.
Yeah, go for it.
Just because, we were talking that everyone needs to be part of the workflow, everyone in the team needs to be moving on the same direction. But I also wanted to say, as a leader of the team and organizing the work, not everyone have the same skills, not everyone like the same technology, not everyone use the same software. So the understanding of how to make a project successful is actually to understand who in the team need to be using what, and where in the team. You have the creative team, you have the technical team, you have the 3D team, you have the interior design team, the architecture team, and in every single discipline, that's the word. In every single discipline, you have different people that use different things. And you have the one that it will be just working on Revit and they don't care how the other ones are dreaming on AI or using the renders or working in a workflow. And those people, they are happy and they are really, really key important to make sure that the project goes to construction. And those one working on Revit and working on technical drawings are probably telling the team that is dreaming, guys, we can get pushed until that point, but then we need to make sure the building is getting built. So we need to come back to reality. So, I mean, everyone needs to be part of a workflow, and we have a workflow as AI, and it's a back and forth, and it's not a one straightforward. Every project is different, and every project has their own process of how it's going to be developed. Every client is different, and that will influence as well of what kind of workflow you do. But most important, as a leader and as a leader of the team and kind of splitting the work, is really understanding what everyone is capable of and what everyone likes to be working on. And you cannot push everyone in the team to be working in the same workflow, because it will not happen. And you have those amazing people that are really good in some other stages of the project. So, I mean, it's not about an image, it's not about only technical, but it is a combination of key people and putting the people in the right position to make sure that the final play gets successful, gets to construction, and have the better quality possible in construction site. So it's a back and forth and a game changer between AI and what is not AI, and our standard tool that we have been using nowadays for many years.
I always say it's like leveraging AI where it makes sense. And I'm sure Nick and Khaled know this very well. Since these tools are always updating, if all of a sudden something makes more sense than the previous way you did it, the previous tool is gone, most likely. You know, we had a long period of time where Midjourney, a specific AI generating tool, was very popular. Wasn't necessarily super useful, but it was an amazing tool at the time. Then you had the next tool, and it was just like, that tool is no longer relevant. Just like that, night and day. And I think it will continue to do this. Every single new release of an AI tool is going to shake the ground. And I think, going back to Nick and having someone in your office that's constantly up to date so that you're not behind and you're essentially updating, constantly making sure you can leverage AI to its max. And that leads me to the last question before we open to audience questions. And it's about unlocking the future possibilities with AI. And is there something you believe architects, designers, developers are soon going to have the ability to use AI that currently feels impossible? And before I pass it over, I personally think that the second coding with AI is, let's say, locked down, very capable. Software is not going to be something you purchase, but rather something you kind of prompt into existence. And the capabilities of that are going to be dramatically important. I mean, I'm talking any of the presentations you saw here. You could do simulations, you can do facade panel optimizations, you can do basically anything you can think of, as long as you can describe what you want as a prompt to an AI that is fully code capable. We're going to unlock some massive capabilities. So are there any other exciting possibilities that you guys are looking forward to that you don't have access to at the moment?
Technical drawings. That's not there yet. Very long to go.
Actually, maybe, sorry? What did you say?
Technical drawings.
Technical.
So, actually, regarding what is the capabilities of AI in the future going to be, I want to touch on Maya's word regarding dimensions. Right now, people doesn't understand more than the fourth dimension. And right now, AI and all of these technologies are just trying to explain things that we didn't even could visualize it before. Humans usually understands with visuals more than hearing or reading things. So I believe in the coming future, we will, the new generations will understand things that we even in our wildest imaginations, we didn't even think about it, like how to create an atom in a bigger size with energy or something like this. This is a wild thoughts, a computer in the size of an atom, stuff like this. We didn't even think about it right now because these technologies are way beyond our level. But these jumps will come very fast because humanity started with hunting 10,000 years, let's say. And then after that, they adapted agriculture for, let's say, 2,000 years, then atom bomb 200 years, and computers and stuff like this 50 years. So it's jumping very rapidly, and AI will speed up the whole process till the point that the people will need devices to understand what's going on. And this is something that everyone should understand. Your mental power and your mental energy should be a responsibility, like what Khalid said, should be a responsibility to be existing in this market and in this world. Because once you, there is like 3 types of people. There is the people, initiative people who adapt very fast, and there is people who ignorance people. They reject always the new things until they are forced to adapt it. And there are people who are followers, who follow in the middle, and they're the most people. So your influence on the most of the people, if you consider yourself as an initiative person, and I believe most of the people here are initiative people because you care about this subject and you came to listen to our conversation and to this conversation. So you need to influence people on understanding what's coming. And understanding what's coming is the most important topic right now, because really in your wildest and craziest thoughts or dreams, you won't understand what's going to come, because no one else, no one in the whole world understands what's going to come. Because once we reach to a point that it's a super intelligence, this is the point where it's creating stuff and creating ideas that we will start adapting, and learning from it, not just study it. It's a whole new world we're coming to, and it's something that you need to train your mind to adapt it.
It's almost like a new species, right?
Yeah, it's really wild, actually.
Okay, I think future-wise, I think what if there's the possibility that AI now we're using as a digital tool, but what if the building in the near future has AI embedded with it? The architecture itself will be adaptive in a way that we use our buildings, that the building itself will be moving together with the people that are using it. Because architecture historically is like frozen in time. You build it, you design it, you build it, and then it stays that way. But what if in the future, embedded with AI, with how quickly it evolves, it's embedded in the building, and yeah, it moves, and it responds to the end users. But at the end of the day, there's a catch to that, because the problem there is, what if architects also become passively just relied on AI? So I think that's something that we are, that's a different discussion. But yeah, future-wise, I think it's a good tool that we have, and it would be nice to have buildings that move together with its end user.
It almost reminds me of metabolic architecture style, right? Where
exactly, but it's learning. The building is learning as the end users are using the building itself. Not just it's moving because it's designed that way, but it's learning and it progresses. So maybe in the future we'll have those buildings in, or maybe everything is just not there. We don't know yet. What do you think?
I don't know what's happening. I don't know what's happening tomorrow. Honestly, I'm not going to talk about the future, because I solely think that the juxtaposition of this conversation today is that we are living the future right now, because we're way ahead of our time. And even for ourselves, as extensive users of AI tools in different ways and in our respective backgrounds, it's kind of overwhelming, right? Do you guys agree? It's kind of overwhelming, That's my 24/7, and I'm telling you it's overwhelming. So I can only imagine what it's like for you guys. But here's the kick. So you were talking about, for example, what's yet to come and so on. So for example, the barrier to entry for SaaS products right now is almost zero. Because I can literally vibe code anything today. Vibe code, that means make me a platform that maybe helps enhance the performance of the building through different facade designs. Whether it was parametric architecture or parametric, let's say, for example, skin or breathable skin, or it adapts according to the sunlight or to the wind or certain weather conditions. So there you go. You can literally vibe code this. And if it picks up a little bit of traction, you can hard code it in the back end. And now you have a multi-billion-dollar SaaS product at the tip of your hands. Drew, I want you to tell me, for ballpark it, how much would that have costed without doing it this via AI? And how much time would have that costed us?
Exactly. Like you're literally saying vibe coding, which is like the least amount of experience you could possibly imagine, but like cost-wise, time-wise, it's not even in the ballpark. We're talking years, hundreds of thousands of dollars for the software that you can get, in minutes, which is fantastic.
So imagine now that I have this product, which is like white labeled, for example, for other companies to use, but it's following, like, let's say, certain guidelines, and in let's say in a very responsive, and there's some sort of like responsibility behind it, where the only materials that you can use is whatever is there are presets, for example, and then you can, instead of you generating images, you're actually generating an entire let's say your prompt is triggering an entire system in the back end.
You're curating everything.
You're curating everything, but in the back end, there's an entire system that's working. So it's linked. It's a trigger effect, right? So let's say, give me options. So instead of you generating these options, that SaaS product, for example, guys, you're welcome. That could be an incredible idea, just to test these facades.
You were asking about what do we want AI to be able to do for us in the future, that it's not happening now. And again, we're talking about options and things. I want it. Has anyone heard about BIM level 7? Like I was working at a project in an office that was doing research at BIM level 7. I'm not going to explain what that is, but we want AI level 7. Level 4 is 4D time. I want us to understand the implications of what we've designed today well into the future, so that we might have options where we go, actually, what we did today impacted positively, improved the health of people.
We learn from the options.
We have a legacy to leave the world a better place, that we didn't use this tool to somehow just make it look a little bit better while feeling and making people feel worse. Quick, done. We know our time is.
2 seconds.
No.
I'll make it very quickly. I was going to go for something very niche, actually, which is immersive worlds. So you can start generating, not 3D models necessarily, but I'm going to give a term that can't even give you the full definition of, Gaussian splats. So where now you can upload an image or even text prompt it into an immersive 3D world that you can now fly through, and even hook up to VR headsets and fully explore the space itself. So now you've just skipped entirely image generating, hand sketches, 3D modeling, all of that. And I already know that we are there to an extent. There are tools available out there. But I'm very, very curious to see how much that improves in the very near future as well.
Thank you, guys. So to wrap this up, there's so much to talk about with AI. It's such a general and diverse topic, ever evolving, impacts every single person differently. And I hope you guys enjoyed the conversation. And if there's any questions in the audience, please feel free. We'll try to cater to a few of you. We still have time? Khalas?
Take it, Drew. This is your time, Drew.
Okay.
I think this is our prompt to the audience to say, who are you going to be in our photo?
All right.
Thank
no
you.
questions? Thank you so much, guys.
Thank you.
Thank you, everyone.
And their implications for facade design. Please welcome Nandan Tafkar, Senior Associate Director, Climate Response ESG Advisory at Jacobs.
Thank you, everyone. Can you all hear me? Right. Thanks all. My name is Nandan. I'm from Jacobs, and as she said, I work with the sustainability team. So, getting right into it. Here's a quick agenda. This is what we'll be talking about. So where we are, and then we'll go through the key elements. So climate change resilience, net zero carbon, some of the current and future sustainability regulations and certifications, and some case studies of what we've done and what's possible. So jumping right into it. So where are we? Right, so just to establish the facts at the beginning, we all know that greenhouse gases are the largest contributor of global warming. Now, another word for global warming is radiative forcing. That'll come in later on, but basically it's radiative forcing. What's happening right now is currently the carbon dioxide is the largest by contribution of the greenhouse gases. So it contributes around 80% of all of the greenhouse gases. The current carbon dioxide concentration is 432 ppm, which is more than 50% more than pre-industrial era, which can be pretty huge. Now, what this means for the world is, you might have heard that, you might have heard of 1.5 degrees, 2 degrees from the climate change agreement. Now, it's a consensus that 1.5 degrees is past. It's very difficult to get to 1.5. But we can still get to below 2 degrees. And the target right now globally is 1.8 degrees. Now, what does it mean for 1.8 degrees? So for 1.8 degrees, there's a carbon budget that the world has, which is how much carbon dioxide is there in the atmosphere, or how much greenhouse gases are there in the atmosphere. The budget is 525 gigatons of carbon dioxide. We cannot go above it. But what we can do is we can manage our rate of emissions. So current rate of emissions are 58 gigatons per annum. And if we were to get to if we were to meet our climate targets of 1.8 degrees, then we would have to reduce it to 30 gigatons. So that's our target per year. We have to reduce it from 58 to 30. So it's almost half of it, which can be quite a daunting task. But we come to the next point where, what can we as real estate professionals or designers do? The built environment is responsible for 40% of the global energy-related carbon emissions, which means it's building, design, construction, and operations are perhaps the biggest contributor to climate change, but it also means we have some of the biggest opportunities to reduce climate change and responsibilities in that sense as well. It all comes down to what path we take. As I said, we have to reduce from 58 to 30 by 2035. So what path do we take? Right. So this is, I won't go into the concepts, but there's a concept called a socio-economic pathway, which is the path that we take as humanity. Right now, without a doubt, and you would all agree, we are at regional rivalry. And that is actually a path which was set out in some of the IPCC climate change agreements. But this is where we are. Obviously, we see the direction we're going in. It's not really helping. Where we need to get to in order to meet our climate targets of 1.8 degrees is sustainability. So we have to go from SSP3 to SSP1. If you see the global risks from the World Economic Forum, look at the long term. All of the long term, the top 3 long term risks are those related to climate change. So what that sort of points towards is, to counter risks on the long term, not even so long term, on a 10-year horizon, we'll need to act to move from SSP3, where we currently seem to be, to SSP1, which is a sustainable pathway. Now, this is where it comes to the crux of where we are. So today we are at 1.4 degrees. We thought we'll be better off, but no, we're pretty high. We're very close to 1.5, which is why we can't meet 1.5. But we're at 1.4 today. Our target is SSP1, and the projection is with SSP1 pathway, the temperature rise by 2100 will be 1.8 degrees. However, if we don't act, if we carry out on the trajectory that we're going right now, then we would still be on the SSP3 pathway, which would be a 3-degree temperature rise. Now, let's see some of a summary of the effects that can come through because of that. So, starting with sea level, even with 1.8 degrees, there will still be around 0.5 meters sea level rise, which will displace around 45, 50 million people. However, if we do not act, the sea level rise would be 7 meters by 2100. And you'll have some catastrophic considerations around glaciers melting and those kind of things as well. Which comes to fresh water, which would again be a huge catastrophe. See, even with 1.8, it is still a risk. With 3 degrees, it'll be a severe water shortage all over the world. You can just see even now, this is from current scenario, and you see all of this gorge around the glaciers has gone dry. So that you see the effects of 1.4 degrees today, but then 3 degrees would be obviously catastrophic. And then similarly on food systems as well. So you see with 3 degrees, there would be a huge impact on the food systems. Fish species would go extinct, and food crops would, crop yields would reduce by 10% almost. Now, one thing to note is 2100 is not that far away. We think it's far away, but by 2100, our kids would be old people. And that's the time they would need a good environment. So, bank balances do help, but beyond bank balances, they would also need a good environment, and then we kind of have some control in our hand, where if we go by the climate adaptation and mitigation pathways, we can still contribute towards keeping the temperature rise within limits. So what we need to do is avoid a 3-degree temperature rise, and we do that by climate change mitigation, so decarbonization, if you might. And we need to be prepared for 1.8-degree temperature rise, because that's still going to happen, and that's still going to have effects on how the world runs. So we will still need an adaptation pathway. We'll still need climate change resilience as well to go along with decarbonization. And you see a dollar sign. Well, it's not just losing money, it's also opportunity. So there's a lot of opportunities with climate change mitigation and adaptation. I mean, just right now I saw, there's facade exhibitors who have, facade elements with good thermal performance, BIPVs, all these will help. So the role of facade systems is quite important. Now, I'm a designer. I design green buildings, right, from the design stage to the operational stage. What we've seen is facade systems are probably some of the earliest and some of the most impactful systems for energy demand reduction and for integrated climate change. And you see some of the examples over here, and we'll come down to those examples in the case studies. So jumping into resilience and climate change adaptation, right? You see on the right, what happened from the pre-industrial era to the age of AI and data centers. We've gone up to 1.4 degrees temperature rise. On the bottom right is the direct risks of climate change, which is, all of them are environmentally related. But how do facade systems contribute? With resilience, they can contribute to extreme heat. So fire resistance is important, and we'll come to that, but primarily using non-inflammable material is one easy way of doing it. High solar reflective index materials. Now, remember I said radiative forcing. Solar reflective index is negative radiative forcing. So if carbon dioxide is making the earth warmer, solar reflective index, high SRI materials, has a cooling effect on the earth. So that has some positive impacts. But then we can have intense rainfall, and there's facade systems we can help with that. So vegetated facades will slow the flow of waters. Structural and durability considerations are important. So for example, there was this huge deluge of heavy rainfall in Delhi airport a couple of years back, and that caused the structure to collapse. Now, had heavy rainfall been considered beyond just the current rainfall, but a few future projections of rainfall, had they been considered in the structural considerations, then that might have been avoided. But also drought resilience, where it can, facade systems can help rainwater capturing systems, and there will be desertification that's happening, and there will be increased dust. So air tightness criteria, which is quite important for that as well. So going to the risks, there's a couple of types of risks. One is the physical risk, which is the direct impacts of climate change, right? So that includes extreme heat. As I said, fire-resistant materials. We have, it's simple things. If we consider rock wool, mineral wool instead of polystyrene, we're reducing some of the risks. We can use foam glass for roof insulation. Again, it's a non-inflammable material, so we can use that. Straightforward solutions. Intense rainfall, again, as I said, vegetated facades. We see an example from Dubai Expo 2020. It's possible to have good vegetated facades even over here. They've disassembled this one, but this was quite amazing. And of course, there will be increased dust from desertification. So there are air tightness criteria that we can follow. ASHRAE 90.1, for example, has air tightness criteria for facades. And we'll come down to that. ASHRAE has been sort of neglected because you just see what's in the codes or what's in the green building. ASHRAE is sort of implied. But following those is quite important and quite effective as well. The second one, beyond the physical risks, is the transition risks. So what's happening is regulations and policy will change rapidly within the next 3 to 5 years. 2030 is approaching soon. So we will see some regulation mechanisms around carbon pricing, carbon tax, and so on. Already, the EU zone has started with the ETS, the emissions trading scheme, and the CBAM. So that's the carbon border adjustment mechanism, where how much emissions are emitted during the manufacturing of a facade system will have an implication, and there might be some financial implications as well. So again, having more sustainable facade systems will make you prepared for these eventualities. So if you see what the quote from Warren Buffett, so predicting rain doesn't count, building arcs does, which is, if you can spend time in speculating if there is going to be climate change, there's not going to be climate change, and how much it's going to increase, doesn't really matter. What matters is you're resilient for it. So you prepare, you have the systems in place in case that happens. Then there's geopolitical risks. So you see what's happening. But what's important is countering climate change risks. So geopolitical risks will compound onto the climate change risks. But there's things that we can do. So having local supply chains, having local manufacturing in every geographical region will counter a lot of the geopolitical risks that we see. And we already see a lot of manufacturers starting to add in hubs in UAE and Saudi Arabia and the region. UAE has initiatives, so there's Make It in the Emirates, and then there's also circular economy considerations that we have within UAE. So UAE is accelerating this quite fast. They see the risks, but they see the opportunities as well. We'll move on to climate change mitigation. So the first part was about adapting to a 1.8 degree world. But this is reducing the impacts of what we're doing today on the future. We start with net zero carbon. So this is an equation for net zero carbon, basically. So it's embodied carbon, so the carbon in the materials and in construction, plus operational carbon, plus the user carbon, minus renewable energy, equal to 0. So you've got two options. You can increase renewable energy a lot, which is expensive, or you can do both. So you can include renewable energy, but also reduce embodied carbon and operational carbon as much as possible. And that's where the focus is of facade systems. You can have low carbon materials. If you look at this, again, I won't go into the details, but A1 to A3 are the materials, the cradle to gate kind of impact. So that goes into the manufacturing of facade systems. There's B6 down there, the operational carbon. If I can get this thing to work, but I can't. B6 is the operational carbon. So if you have high insulation, high performance facades, that helps reduce the operational carbon, the operational energy. So there's, again, a lot of synergies where facade systems can contribute towards these things. Again, we've got the embodied and the operational side of things. Won't go into too many detail, but these are some of the embodied carbon elements that we can go for. It goes into design of facade systems, so primarily designing facade systems such that the carbon elements are lower, the embodied carbon elements are lower, is a good way of doing it. And then the construction of facade systems is important as well. So that's another opportunity that you have. So you might see this on the lower right-hand side. We've got environmental product declarations. We can get those, and those are being more and more mandated around the world and the region. On the operational side, we see there's a lot of opportunities. So primarily thermal performance of facade systems. So again, some of these would be really obvious. Insulation, glazing, G values. But then there's also opportunities for integration of renewable energy with BIPVs. So that is, again, another opportunity that we have. And you see all of these in the examples here. There are sustainability regulations and certifications. So these are some of the regulations and certifications going on. I think the one to focus on is ASHRAE requirements. So ASHRAE 90.1 requirements are often overlooked. And it's simple. There's ASHRAE 90.1 section 5.4 for facades. And if you go to that, it gives some really good information about how to specify and reduce energy through facade systems. So quite useful. And then another thing to look at is LEED version 4.1 and LEED version 5. So we've moved from LEED version 4.1, and we're moving towards LEED version 5. So that's something to keep an eye on. That will have an implication on facade systems going into the future. These are some of the parameters which would be controlled through ASHRAE and design of facade systems. Something which is, again, not really looked at in a lot of details, but it is important, is the air infiltration rate. So some of these say 1.7 liters per square meter per year at 75 pascals. But the codes would give more detailed information. The key elements is to keep an eye on these values, and then, of course, there will be some sensitivity checks as per how you design these facades. There is a lot of opportunity to have low energy design through them. We'll come down to the case studies. So primarily, to start with, is King Salman International Airport that we've been working on. It was challenging because we were trying to get the performance of facades required for different typologies within the airport. So we've got terminal buildings, we've got air traffic control towers, we've got warehouses. So, and each of them have different requirements. But how you meet those requirements and still have a net zero carbon ready design. So that was some of the there was some of the considerations. We had non-inflammable installation everywhere. And then some of the trade-offs we had to manage were, for example, the control towers can't have high shading coefficients. So how do you then balance it out through other elements? So you can have the remaining facade systems, the roof systems, the wall systems, which have a higher U value glass. So there is ways in which you can balance these things out. And then finally, we had them ready to be to design in integration of BIPVs or building integrated photovoltaics. So that's some of the things that have been implemented on KSIA. The next case study is around Dubai Expo 2020. Again, we were the program managers. We were not the designers for each of them. But then there were some sustainability and facade-related KPI that we had across all of the designers. So you see some of the examples. The UAE Pavilion had amazing integrated solar PVs, which looks like the wings of a falcon. Sustainability Pavilion, which is the Terra on the left side, that had a slew of features. So you can see all of them. Some of the important ones were, in addition to the operational carbon, there was embodied carbon reduction through life cycle embodied carbon assessment. So we did go for low embodied carbon assessments and low carbon materials on it. And then EPDs, environmental product declarations, were almost mandated throughout the expo. And all of the manufacturers and the contractors were made to provide EPDs. And that's something that's going to be going on for the coming years. EPDs will be important as well. That comes to the end of my presentation. But yeah, thank you very much. And there's no questions and answers, right? Or are they? All right, thanks all.
Thank you, Nandan. Ladies and gentlemen, moving on to next, please welcome Prathush Sreedharan, Specification Leader, Middle East, Axalta Coating Systems.
Hello. Good afternoon, all. Over the next few minutes, I would like to talk with you about a survey we conducted on external facade coatings and the subsequent resultant launch we did for Alesta HD. So this is a class 3 product which we are launching today at Zak. When we decided to launch this class 3 product, we had two options. One option was to stick to the available product in our portfolio, which is available in other countries, which we can directly launch in the market. And the other option was to identify the gap in the market and build a solution which exceeds the requirement of the current benchmark in class 3 and which can solve the challenges in the projects. Before I go into detail about Alesta HD, I'll quickly brief about Axalta. Axalta is a legacy company when you talk about coatings. More than 150 years of expertise in coatings, 40 plus years of expertise in fluoropolymer chemistry, 600 plus patents in our name, and you know what? We are just beginning. So let's see what Alesta HD is about. Following the survey we conducted, we identified 4 key aspects of the product, which is very important when you talk about landmark projects, when you talk about high-rise buildings. And the idea for this product is to solve these challenges. Let me show you what those 4 challenges we identified are. So about the color and finish of the product. Rather than building a portfolio of color, what we decided was to have an expansive, open range of color. So you name it, we make it. That's the idea which we built on Alesta HD. Different colors, finishes, and effects. And about the durability and warranty. So we ran a lot of tests, to identify the limits in the product and to test the product to the limits. And at Alesta HD, we can offer up to 30 years warranty and 50 years of service life. This is, I would say, the best what any coating manufacturer can offer in the market today. And when you talk about compatibility of the product with subsequent finishes, you're talking about sealants, you're talking about different substrate, steel and aluminum. We have solution, we have devised the product and we have tested the product with a lot of different parameters, different type of sealants, different type of primers for different substrates. And we have built a complete portfolio for the product. And finally, about the added value and synergy of product. So what do we mean by synergy? When you use our product along with your system, it amplifies the value of the product itself or your system itself. So we tested the product for all the fire performance requirements to comply with 13501. Our product can achieve A1, A2 classification depending on the thickness, what you use in your project. About sustainability, to contribute for the building envelope U value, our product can be tested for SRI values, EPD, Environment Product Declaration, Life Cycle Assessment Certificate, you name it, we have it all. So this is basically about the skeleton of the product. And let's see how our Alesta HD differentiates from the conventional product available in the market. So when you talk about fluoropolymer chemistry, you're talking about PVDF liquid and FEVE powder. So, yeah. So imagine this is the conventional product, what you have in market. I've just picked this pic because this is one of our references back in 2009 where we used our conventional fluoropolymer technology. So imagine this is the product, what you have in market now. So what do we have as an added value in Alesta HD, which we have launched in the Middle East market? So we have a right blend of properties of liquid and powder in one product. So you're talking about a liquid-like finish, soft reflections. It retains original color and glows over extended period than the conventional products available in the market. UV resistance, which is very important when you talk about Middle East market, impact strengths, adhesion, corrosion resistance. Conventionally, if you have to test the product as per the standard for 4,000, we have exceeded this limit. And about the abrasion resistance and low dirt pickup technology. This is something new in the market. So we have developed a product with high TG, which means the product doesn't soften at high temperature. So basically what happens when you have an ambient temperature of 45, the surface temperature of the facade will be much higher than the ambient temperature. And when this temperature exceeds the glass transition temperature of the product, the molecular structure of the product changes, which means it softens on the surface. And when it softens, what happens is that the product gets abraded and the product creates a friction which allows the dirt to stick to it. So we have created a new surface technology which allows our product to be much higher in the glass transition temperature and which allows a better cleaning regime for the product. So conventionally, if you have to clean the product every year, you can extend the cleaning regime with our product. I mean, we have this covered in the cleaning manual. And this slide is basically prepared because I was excited and discussing about the launch of our product with a consultant, but he commented, okay, obviously you have the right product, but what about the complete system which you can offer for the project? So that's why at this point of time, Axalta has a complete comprehensive offer which we can offer for your complete project as a package. So if you're talking about internal application, if you're talking about external application, if you're talking about steel substrates, if you're talking about galvanized steel, if you're talking about mild steel, we have solution for everything in your project. And we are a comprehensive coating manufacturer who produces the product locally in the Middle East. I mean, I will just go through that. And this is one of the most important and interesting slide for me. I'm sure you might have seen the stadium if you have watched the US match. And this is one of the references which is very close to Axalta. So this is Sophie Stadium where Axalta has protected the metal elements of this project. And if you see the reference of this project, you can see this is one of the world's most expensive stadium, more than $5 billion US. FIFA World Cup 2026 is happening in this stadium, more than 8 matches. Olympics 2028 is designed for this. And you know what, Sophie, they have chosen Axalta to protect their assets. And about the manufacturing facilities, we have a global reach spread across the world. However, you can see the small little falcon in the center flying. So this is us, UAE. So we produce locally here in Ras Al Khaimah. I mean, we would like to support the Make in UAE initiative. And Alesta HD, which we are launching, is also being produced in UAE. And this is a broad picture about the sustainability priorities and initiatives what Axalta has globally. So we have greenhouse gas emission, reduction pledges. We have carbon neutrality, like say, operational by 2050. So we have these listed details. However, rather than going into detail about this is just a summary about what we have in sustainable priorities. And that's it. Thank you. one more point. This is not a technical presentation. This is a descriptive presentation. We have a separate technical presentation available for the product if you would like to go into details on the technicalities. Thank you. If you have any questions, you can ask us, or if you, we are always available at the desk, so we can come. We can meet you and explain to you if you have any clarifications. Thank you.
Thank you, Prathush. Our next session explores the intersection of intelligent facade systems, computational design, and building access strategies. Please welcome Shyam Chand, Associate Consultant, Building Access, WSP, and Giselle Javidan, Consultant, Building Enclosures, WSP.
Good afternoon, everyone. On behalf of WSP Building Enclosure, my name is Giselle Javidan. I'm leading the computational design team and co-hosting this presentation with my colleague Shyam, who's leading the facade access team. We are going to present how we're integrating intelligence skins and access with computational design. In the first section, I will explain how we are using our computational design workflow to convert a complex geometry into buildable intelligence system. 20 years ago, the question was how to generate a complex geometry. Today, with all the development through the softwares, engineering, and the tools, the question is no more how to generate the geometry. We can generate any complex geometry that we can imagine. Now, the question is how we can build it, how we can make it affordable. Can we access it, or can we make it perform? The facade is not just a geometry. It is actually an interface between different disciplines, between architecture, engineering, construction, operation, and also the human interface. Each of these disciplines have different perspectives over the facade. Architects, they want it beautiful and flexibility in design. Engineers, they're looking at performance and the efficiency. Contractor, they want it simple and buildable. And of course, the client want it cost efficient. So the facade is not just a simple geometry. It's actually 4 different problems competing together. And these 4 competing problems should converge to one optimum solution. This is where actually the computational design step in and show its power. Each of these disciplines have different goals and perspective over what they want from the facade. A computational design approach, including AI algorithms and parametric design, will give the ability to optimize all the goals at the same time. So we can have a workflow who look at all the objectives, optimize all the goals that each of these disciplines have at the same time, and also give us the ability to study how any decision of any disciplines can affect the other disciplines. The first step of our computational design workflow is actually not to optimize the geometry, is to understand its complexity. So first, we don't look at the geometry and think that how complex it is. We ask questions of where this complexity sits and what should be our strategy to face each of them. In this particular example, we were facing a very complicated facade. It's a double curve twisted one. What we have done first to understand the complexity was to divide it to different zones, running a curvature analysis to understand how different kind of geometry, typology we have for this facade. Quantifying the complexity, we can move on to the next step. Now we know what is the complexity of our facade and where are these complexities sits. So the next step is to how we are going to manage that. In this particular example, we have a double curve twisted facade. In this type of facade, the potential, each of these panels potentially can be unique. But we know that unique panels might not be affordable from cost efficiency or maybe fabricatable. So instead of approaching any of them and figure out how we can make them affordable or constructible, we use AI algorithm, Gaussian mixture algorithm, to cluster all of these panels to the families that have similarity in the terms of curvature, area, and dimension. Each of these options are showing different alternatives for balancing the design intent and the constructibility of these panels. In addition to geometry, understanding the complexity of geometry and clustering it to the different strategy, the performance of the facade is also essential. So in our computational design workflow, the geometry does not just govern the design, it's one of the parameters that we are considering. Because facade initially is supposed to control inside from outside, protect inside from outside. To achieve that, a performance analysis regarding the daylight, visual comfort, radiation, and glare always run through our computational design workflows, in addition to the geometry clustering and geometry decoding. The last but not the least is studying the facade axis. No matter how much a facade is rationalized, and no matter how it performs very well or efficient, but the question will always remain that does it maintain? A facade that doesn't have maintenance and access appropriately will gradually become an operational problem. In this example, we use computational design workflows and our algorithms to automate how we can have access to each point or each particular area of this facade. The output would be a gradient color or a visual gradient color of map, which shows each of these points are accessible, not accessible, and we need to have a different strategy to make them accessible. All this together actually shape our computational design workflows through the facade engineering. Next session, my colleague explained more specifically how computational design actually applied in the facade axis.
Thanks, Giselle. I think the mic is not recorded. Yeah, there you go. So Giselle basically touched base on what's happening with respect to access and how access is actually required to maintain the facades. A facade design, how complex you want. If it's not accessible, it's an ISO. It turned out to be a tragic outcome. So that's where facade access comes in and where computational design basically clubs in and helps in to understand these complex facades. Let me go to the first screen. So the main challenges we have with respect to these kind of facades are basically, what kind of system are we going to put in that place? Are we going to have MU? Are we going to have BMU systems? Are we going to have upsails? As you see in the previous slide, there are zones wherein the BMU would not be able to access. And the question would be, what would be that system be at that location? So that's basically optimization of facade systems. The next one is basically positioning of anchor points, so be it restraint points, be it upsail anchor points, and so forth, with various complex facades that you get, not only the ones that you have that goes in a straight inclined manner or so forth. Now we have curving facades that are conforming to organic shapes and so forth. And if these go to 100, 200 meters, it's quite difficult for having a BMU system to access that areas. Again, if you're going to have upsail system at that locations, we need to position anchor points, and it's quite difficult for us to actually look at it from a simplistic viewpoint by just rotating 3D models or using 2D CAD drawings. The other one is positioning of upsailers on complex facades. Now, the thing I've seen in most of the drawings are basically, yep, that will be carried out by upsail people, but they are not supermen. it needs to be, the facade needs to be designed in a manner that, yes, it's accessible by upsailers. He can put his foot in, he can rest on the facade and so forth. So that requires designing of the facade system as well as its shape. It should be in a manner that it is suitable for upsail personnel. The other one is complex movement of systems, not only glazing systems within the floor plan. We also use that for whilst looking at the new positioning and so forth. Let me go to the slide. So this is where I started to mean about complex facades, wherein you have a structure wherein people are carrying out upsailing. Now, as you can see, as the facade actually turns in and out, it's quite complex to understand where these anchor points would be. Now, I've taken out into a 2D sketch. Basically says here, if that being a reference point, if you're having two pieces of glazing, one at the back and the front, the one at the back, it's much easier in the sense that you can easily have a cradle drop down. But at the same time, an upsail personnel, on the other hand, for moving around in such kind of glazing elements, it would be quite difficult to understand where these anchor points would be. What we have done and what makes our system much smarter is basically we have done scripts within the facade design, and that's within the plugins that we have for while designing facades, that we put this in, so we can clearly put in parameters such as the amount of reach that is required for a person sitting on a cradle to access the facade, as well as where the anchor points needs to be designed. Now there are a multiple number of codes which I won't go through that basically defines at what points anchor points needs to be. For example, the 20-degree inclination and so forth. But that's all designed by standards and codes. The next one is smarter integration into facades. Now, the other thing that we have done with our computational team is basically, integrating facade access into the facade design. And just as I had shown in the other slide, here what we have done is, you might have walked through DWTC, and I don't know if you have ever seen a cradle system, but it's smartly integrated into the sunshade louvers. So pretty much you wouldn't see that system there until it's hanging. If you take that out, you wouldn't see a system in. I myself have been surprised, although I have been working on the project. But that system goes in. The things that we have put in is basically the parameters, that is the cradle reach, what kind of cradle system needs to be put in, the sun shading elements, and all the other facade parameters that goes into the design of that shading element has been plugged in with the access requirements. And that's basically a plug-in, neither be Grasshopper, it can go in number of other models that we have worked in. And this is another complex geometry. And this is a project that's actually been built in Saudi, where we have upsailers moving around a circular facade. If it was circular, it was easy. With that, we have triangulated facades that project out, and that projects out in different angles and so forth. And now positioning people in these kind of zones was quite difficult. So what we have done in our design with the computational team is to actually define what would be the ergonomic condition, and taking into consideration personal geometry with respect to how much his feet could move in and so forth, his feet can twist and so forth. We have defined in what position he'll be at various locations, and this has been a dictating factor on telling us what kind of system needs to be placed where on the building geometry. Now, this shows the model in 3D, and you could clearly see it's quite complex. A person moving around, adding to the complexities, these triangulated facades wherein a person actually needs to move in different directions. What we had come in to understand is basically it would be not only required for us to have anchor systems, we would also need to have temporary systems that we need to bring in place. And this was basically done all through computational design, basically having the system to analyze the entire building facade and to let us know what and at which position these people would need to be placed. So it's quite complex, and it wouldn't be able to be done if you're doing it manually. I can guarantee you that. Next one is another shape that we have taken. That project over there is not real, but let me tell you, that shape is real, and this, due to confidential reasons, we cannot put that the entire project in, but there's a situation wherein personnel are required to move down, and through our plugins, what we could understand is, taking into consideration gravity, the shape of the surface, and so forth, people would tend to go down in an angular fashion, which means we would either have to have additional systems on the right, onto the left, or anchor systems that would need to be placed on the facade. Okay. This is basically the study that we had done, and this is basically in Rhino and Grasshopper, where we are actually studying, doing a vector analysis of the surfaces. So where's the normal, where's the, gravitational vector, and how the personal footing is actually going to be stepped onto the facade. That being said, go back, yep. Okay. Okay, I don't know. Yeah. So these guys who are coming down basically actually show where anchor points are required. Unfortunately, it's not coming here, but they actually show where these anchor points would be required when he moves around with these surfaces. The other one is basically glazing replacement, a movement of glazing within the building floor plans. And that's something that's not studied much. And it actually helps in letting us know what kind of glazing can be placed in the building and what can be placed for carrying out glazing replacement from the interior of the facade. And this is quite important. It's basically a stance wherein you can say, do you really need a glazing replacement to be carried from the exterior of the facade, wherein you require a bigger system with bigger loading requirements and so forth. This has also been translated by our team into MUP studies and so forth. That's much complex, wherein the MUP system basically studies the surface and lets us know, is access being possible. Now, all these does not apply for small projects here. Small projects you should be cool with, but this applies to most of the projects which WSP does as complex projects that we have at the moment. The other one that's much less talked about is wind speed. It's not what happens on things that happen that we talk about. Even the wind speed that you get from your devices does not actually translate to the wind speed at different points on the building facade, because as the shape of the facade changes, you have different wind speeds, and this can be experienced by you going on site and being on a building at different locations. If you've been on a cradle, it wouldn't be windy at the top maybe. Once you come down midway, you might be flying in the air. And now what we are doing at the moment is basically designing designing parameters within the Grasshopper scripts that will actually not only study what would be the wind speed, but its impact on what kind of system should be used at that location. Now, for example, we have restraining systems. That's quite crucial in understanding what kind of restraining systems need to be there and what kind of cradle systems can be used at what location. And this basically determines and drives, what would be our optimum system that we'd be using on the building. Yep. There you go. So from a summary point, yes, through computational design, for these various complex projects, we can build it, we can make it affordable through our design and through our systems that we have and the technology that we have, access it, maintain it, and perform. Thank you.
Thank you. We now move to our panel discussion, focusing on the effect of modern solar control coated glass on our human well-being, latest research, risks and future outlooking challenges, facade systems developing the former Expo 2020 site into a sustainable and human-centric neighborhood. Moderating this discussion is Benjamin Beard, Managing Director, Warner Sabek Dubai. Joining him on stage are Arwa Al-Zabi, Sustainability Consultant at Warner Sabek Dubai, Yasmin Hojik, Hojish, glass specialist, Guardian Glass, Renato Cilento, facade consultant, Turner and Townsend, and Chubriya Kalkura, managing director, John R. Harris and Partners.
Okay, so a warm welcome from the stage and good afternoon to the audience. I'm happy being over here, being the moderator of this panel discussion. We have our panelists already on the stage. I'm going to start this panel discussion with a short presentation. And this presentation is intended to give you a bit of background about some current potential issues. It's going to be a presentation about human beings, about us, about all of us, how we feel, how we behave, and what we need. It's going to be a presentation and panel discussion about light, about glass, about facades, about buildings, and about what we need as a human being, and what potentially could make us sick, or will make us sick. I'm going to start with a short presentation, as I mentioned. I'm from Oana, Dubai. I'm the managing director of the company. I'm here since roughly 2007, working in the Middle East. Now, the Middle East is a bit special in terms of the projects, the design, but also the facade systems. Now, this photo nicely shows our founder, Professor Dr. Oana Sobek, behind glass. And glass is to a certain extent a magic material. It gives us vision to the exterior. It gives us natural daylight transmitting through the glass. It gives us protection from the elements, from rain, wind, noise, any other harmful issues. So glass is a material that we cannot substitute in construction. All of our buildings require glass. We can substitute steel, concrete, everything can be substituted, but glass is a given thing, so we cannot substitute glass. Yeah. So now, talking about us, this is when I saw, because I mentioned our offices worldwide. I'm going to start straight into us as human beings. Now, this slide, you can see on the left-hand side, the blue, it's a percentage of people having depression or anxiety in the United States. On the right-hand side, this is the average daily sunlight exposure for the United States. What we see over here is a clear correlation that the states with high amount of daylight, like California, Texas, they have a lower rate of people suffering depression or anxiety. So the clear correlation between these two things. So we as human beings, we need light. But we not only need light, we need a certain quality of light. So going on, what is light? This is important for us to understand, because if we talk about glass and facades, we need to understand what is light. So light is divided by certain spectral wavelength, starting on the very left-hand side with X-rays, the ultraviolet light, also important, I'm going to come to this later. Then the visible spectrum, which is from about 400 or 380 nanometer wavelengths, the blue light spectrum, up to roughly 760 nanometer wavelength, the infrared. So this is what our human eye can see. Everything above is infrared light, microwave, radio, we cannot see. Now, what we see, this old photo over here, already people in the past understood light is important for human beings. Babies were put in the light because babies were getting sick without light. So there's always a long tradition of working with light, also architecture and light. Soldiers in submarines during the Second World War, people understood that soldiers are getting sick, or human beings are getting sick, if they lack light, especially daylight. So they had this kind of sunlight lamps, exposed the whole body to light. What we see over here, it's a modern society. Our modern society, I'm going to come to this a bit later, we became an indoor species. We spend the vast majority of our time indoor. Look at this photo, we see a lot of people under artificial light. This is the times when the so-called sick building syndrome was created, that we figured out as a human being, as mankind, something makes us sick. Going on, what I mentioned, we became an indoor species. So if you look how we spend our time, about 87% of our time of modern society we spend indoor, inside of rooms. What does it mean? We have only about 7% of exposure to the natural daylight. And keep in mind, we as human beings, we evolved over millions of years under full exposure of the natural daylight that's coming from the sun. This is how we evolved. And only the modern society, we get stamped or cramped into buildings, spending the majority not being exposed to natural sunlight. And this graph shows about 26% we're sleeping, and 44% of the time we're getting natural daylight through glazing, and then about 18% we get light from artificial light sources, bulbs. And these two things are getting quite important. And I'm going to go through this relatively quickly. So artificial light sources, I'm going to cover this. We have Façade discussion, but we're going to cover this relatively quickly because this correlates to daylight coming through glazing. Now this is the spectral transmittance, the two lower graphs. And this then actually correlates to the spectral emittance of artificial light sources. And we're now in an age where using LED light bulbs. Plus we're using highly efficient solar control coated glass, especially in the Middle East. Both of them have one issue. They only transmit or emit the visible spectrum of the light. This is where the energy efficiency comes from. This is where the green building design comes from. This is shown over here. You can see only the visible spectrum is actually given out, is like emitted from modern LED lights. Now, look at the natural light sources, and this is important to consider. Our glazing, we have three things. We have transmittance, so this is the solar spectrum coming through the glass. We have reflection and absorption. Absorption is the amount of kind of energy when the glass is like heating up because of exposure, and the absorption of the solar energy within the glass itself. And this is the thing where modern solar control coatings are working on, that they have a high transmission only in the visible spectrum, but not in the non-visible spectrum. Now these things, look over here, what we see starting from clear glazing, which almost transmits all of the spectrum of the glass, to the modern solar control coated glass. And we can see, similar to the LED light bulbs, we're only getting exposed to the visible spectrum, nothing else, not the infrared, not the UV light, or UV light depending on the type of the glazing. Now, why is this important? And this is, we're going to go through this different wavelength. First of all, UV light transmittance. Modern glazing with the PVB interlayer, so-called laminated safety glass, it kills or it absorbs 99% of the UV light. During the COVID crisis, we all figured out UV light kills bacteria. UV light is killing virus, the COVID virus. So our laminated safety glass blocks 99% of the UV light, because people in the past said UV light is harmful, causing skin cancer, causing color fading. So in the past, people said, okay, our PVB interlayers, so laminated safety glass, should block the UV light. Nowadays, big question mark, should we continue with that? Other things, the blue light spectrum, all of our cell phones have a so-called blue light filter. So in the morning, we as human beings, we need the blue light to wake up. To fall asleep, the blue light is not good at all. So this is why your iPhones, smartphones, whatever, have this filter. Yeah, so then the color of the screen is less bluish, it's more reddish. This is because the blue light spectrum, also blue light, this is a baby. Babies tend to have so-called jaundice, which means that actually the baby's liver cannot clean the blood properly. These babies are put into a chamber, put under blue light, 460 nanometer wavelengths. This helps to clean the blood. So there's a very amazing interaction from us as a human being with sunlight, and also a certain spectral wavelength of the sunlight. I go on, this is the baby, what I just mentioned. Now the blue light spectrum, important for us to wake up in the morning, and we don't need it in the afternoon, otherwise we cannot fall asleep. This is the light that goes into your eyes and then produces certain hormones in our body, the so-called melatonin suppression. Also, this is the thing, for example, here you see a graph that the latest research, we start saying that glazing itself, we're not only looking at the visible light transmittance, VLT, we also start looking at the so-called melanopic light transmittance. This is the actually the kind of transmittance of modern glazing in the blue light spectrum. So the melanopic transmittance is a transmittance of the blue light that's important for us as a human being to wake up in the morning. If we're not exposed to this blue light, we're not waking up, we're feeling tired and sleepy for the whole day. Now the infrared, and there's a very interesting articles nowadays about the infrared. Now the infrared radiation is predominantly cut out by modern solar control coated glass, also by the LED lights. And this is the long wave kind of infrared light. And you can see by this graph over here that nowadays we as a modern society, we have no more exposure to infrared radiation, both from artificial light sources, like our light bulbs, but also for the natural daylight, which comes with the glazing. There's a professor in London from the UCL University. He's talking about the daylight or the so-called actually infrared starvation. And this is, you can see over here, both for artificial lights and also for natural daylight coming through glazing. The infrared is completely cut out, especially with the modern triple silver low E-coated glass. Now, all of these articles now come out because we slowly understand that we as a human being, we are more vulnerable to certain things. So we started optimizing glazing and light bulbs for the energy efficiency, but we didn't optimize these for us as a human being. So there's a lot of publications nowadays. You can see here the infrared starvation crisis. There are even discussions saying that the modern LED light bulbs and modern glazing might be the asbestos of the future. Yeah? So things that all of us will be affected. This professor stating that certain generations of us will suffer from these elements, the lack of exposure to natural light, and then modern LED lights and modern coated glass. You can see over here what the doctors say would happen. And this is just a kind of research, but I think what's important for us as a facade industry, we need to know about that. We need to start thinking about things, how can we do better, and maybe we need to refocus on us as a human being so that all of us can feel better and live in a healthy environment. Another thing, Parkinson is now starting to get treated by red light, so the Parkinson disease. So a lot of examples, we now understand as a human being how important light is for us. For example, if you look at plants, we now have so-called vertical farms or indoor farms. We have plants growing under a light bulb. So for the plants, we exactly know what kind of wavelengths of the solar spectrum these plants need to grow. For us as a human being, it's a bit more complex. We're just at the beginning to fully understand how the human being interacts with the sunlight and what spectral wavelengths we need as a human being. So this brings me to the end of my initial presentation. This brings me to the start of the panel discussion, and I'm very happy starting this panel with the moderators, so with me as a moderator and actually the panelists. I think here we have a few slides. Maybe these are going to run in the background. So we have a nice mix of sustainability consultants, of architects, of glass suppliers, and of product managers with facade background. So maybe let's start with the sustainability consultancy. So what do you think? We've seen that nowadays there's a strong push, for example, in Dubai with the Dubai Green Building Code to have a sustainable building design. Do you think that the needs of the human beings are currently correctly or sufficiently considered, or do you think there's room for improvement for the future? What do you think?
Is this working? Okay.
Maybe a bit closer?
Okay, I hope this is working.
A bit closer, yeah.
Testing.
Yes.
Okay, everyone. So that's actually a good question to discuss. I do actually believe that there's room for improvement, especially that traditional orientation of sustainability only includes the social and the economic impact. The environmental and the economic impact. However, when it comes to the social impact, there's too much to discuss, which is actually overlooked. And Mr. Ben here actually just gave us some examples on the importance of considering a human-centric design to facade generally.
Yeah.
So
now, thinking about the kind of design that we have, and maybe for the architecture, why are our coated glass in the Middle East, and this is maybe a problem that we specifically have in the Middle East, because nowhere else in the world we have so much dark solar control coated glass to keep the solar radiation out. So from an architectural point of view, could it be that we're still following an old Mies van der Rohe Seagram tower design, because still the majority of our buildings are fully glazed, floor-to-ceiling glazed towers? Do you think this might be outdated? We might need to implement more external shading. Can it be implemented in the modern architecture? What do you think about this implementation, about the glazing, advantage, disadvantage, shading? What do you think about this?
Thanks, Benjamin. Good evening, everyone. My name is Subraya. I'm Managing Director of John Harris & Partners. I've been fortunate to work in this region for the last 2.5 decades. And have been fortunate to work with some of the co-consultants, some of the facade consultants, and some of the suppliers in the forum. So thank you for the opportunity. And Benjamin, it was an excellent presentation, technical presentation you started with. And from that as a background, going to the core question that you asked, the architecture, you know, how is the glazing, are we still following what the great architects of maybe 1950s did, or have we moved on in terms of how we use glass in our current buildings? I mean, I would still say we human beings, we are the species of light. I mean, the light is the one which really, essential for the well-being of the human beings. So the natural light is of real importance in our buildings. So we as architects, when we design, we try to encapsulate this natural light to the best we can within our building interiors. And so again, if you see various buildings, some buildings, the natural light is encapsulated a lot better than the others. They have this, it's not just about the quality of, not just about the lux levels, it's the quality of light that comes into the building. So some buildings make a stronger impact than the other buildings, simply because how the natural light is managed and encapsulated within the building. So see, since long time, since I would say since early 1900, making the building transparent has been always the vision of the architects. That's how the revolution happened in early 19th century, when the glass was invented and architects started using the glass to the best they can, with the intent that the inside to outside becomes seamless. That's how in the early 19th century, the buildings such as Mies van der Rohe or Le Corbusier or Louis Kahn, all these great architects started using the glass the best they can to modulate the light inside the building. Ever since, the technology has progressed so much, now we have lot more tools to use the glass in a very effective way. It's not just letting the glass light in, but controlling the quality of light that comes in. Earlier, maybe architects didn't have that option, but now with the technology that we have, I believe we have a lot more tools in our hand to modulate the quality of the light that comes into the building.
And I could maybe do a quick comment. I personally worked in the Seagram Tower years and years ago when I was working for Oana Sobek, New York. I was in the Seagram Tower. It's still the original single glazing from Mies van der Rohe back in the days. It was freezing cold in the winter and super hot in the summer. It was a body-tinted single piece of glass with this bronze color appearance. So for modern standards, horrible. But it was a design intent back in the days. And maybe, Renato, for you as a facade expert, project manager, do you think that nowadays the clients are going into the wrong direction? The market demands this floor-to-ceiling glass, and then the consultants come and project managers, then the facade technical specialist has to step in to reduce how bad glass is, because in the end, glass is one of the weak points in our building envelope in terms of solar heat gain, heat loss. So what's your take? Do you think we can make things better, or are we running in the wrong direction? Is there a magic trick in the future? Maybe Jasmine later on going to explain us about the modern glass. But what's your take on that?
Yeah. So in my experience, so clients, they rely on their consultants, or they rely on the specialists. And this is a topic that is, it's been ongoing for a while, but at the same time, you know that there is the cost-driven. So yeah. Sorry. So the cost is an important parameter, and also there is the belief that the view is very important, and the amount of light that you get into your unit or into your home is also important, no? Because it provides you well-being. But at the same time, we are blocking the UV. This is something that it needs to be influenced, it needs to be explained, it needs to be introduced via many ways. One is pushing the regulations or creating the awareness, showing the benefits, and still there is a long way on that, because I believe that we should start seeing on facade reports that this particular topic, how it is addressed, and then translate it into a specification document. So there is a long process.
Do you think maybe we should look back? If I look at the first double skin facades that were invented in Northern Europe, it was usually an outer skin, then we had Venetian blinds, so active shading, and then a clear inner pane, clear insulating glass unit. Usually no solar control coating, so at active shading in the cavity by Venetian blinds. And then the Venetian blinds could even be tilted with the angle to get more sunlight to the ceiling. And this was actually not solar selective. Yeah. now we have this modern glass, and Jasmine, question for you, from Guardian Glass, one of the world leading glass suppliers, to do a lot of research. I had meetings with your research on D-Lab in the United States about the topic about blue light transmittance and what can we do. What's your current take on that? I mean, you don't want to get blamed in the future selling toxic glass, or you want to sell the healthy glass. So what's your current research? What do you currently take on that?
Thank you. So first, thank you for inviting me here and having this great panel with my colleagues here. Look, we at our best, I would say, what we are trying to do, which is our vision basically, it's to work together from a very early stage to understand all of those different constraints and how we can contribute actually to make people's life better. As you said, we are spending probably 85–90% of the time indoors. And this is something which is also not always constant, right? We have a different climate condition, different weather, different seasons. It's winter, summer, etc. So we don't have one solution that would fit all, right? So you mentioned some of the, double skin facade, basically, that was invented to protect the blind. Otherwise, doesn't have too much of effect, right? So now, when it comes to glass, if you look from the very past, and we discussed about it. You take buildings like Burj Al Arab that we did in 1997 to achieve certain level of solar heat gain coefficient, heat protection of around 20%. We had to use glass that is less than 10% light transmittance, right? So today, to achieve the same protection, we can go up to 40–45% of light. So the evolution is quite important. At the same time, coming to the dear subject of human-centric glass and the blue light transmission, we have done that testing that most of our products are actually letting in that blue spectral light, and but they are always trade-offs, right? So what we can imagine in the future is to say, okay, today we have, went to triple silver coatings. So what's next, right? So this is what's next. This is where we are trying to get this blue light. So what is the trade-off? One of the trade-offs is the color rendering index, right? So to get that blue light in, your color rendering index will go a little bit lower, right? So what is that? That's the color in transmission when you look from inside the room toward the outside. So you will also get a little bit more bluish in the range to, let's say, 85–90% of that color rendering index, right? So those are the small things we can work.
Jasmine, maybe I can quickly, because I was working on a project years and years ago, and the architects wanted to have a body-tinted blue outer substrate for the glass to get a bluish appearance. Then later on, I understood from the client that a fashion company moved in, and they complained because the white was no longer white. Because this is the so-called color rendering index, and how correct is the transmitted light in terms of color reality. So the client complained and they moved out because the colors were not correctly represented because of the body-tinted blue glass having a poor color rendering. So it's a very interesting topic. But Jasmine, coming back to your triple silver low E coating that completely cut out the infrared radiation. I think you, as a glass supplier, you're following the building regulations.
Yes.
And the never-ending kind of appetite for reducing the shading coefficient by increasing the visible light transmittance. So it's a question for us: do we need to start with us as a consultant or architect, or do we need to start with the legislation? That maybe the Dubai Green Building Codes might implement again certain requirements that our coatings have a higher transmittance in the infrared, in the UV light. It's an interesting discussion, and it's also a question, are we there yet? Is there enough research to prove that we need to do that? Because we're counterbalancing the sustainability design. And actually, you're working on this energy modeling and calculating energy demand of cooling of buildings. So do you think that the Dubai Green Building Code might be changed in the future, or that the governments might understand that maybe right now we're going too far in one direction? What do you think?
I do actually see that there is an improvement, a room for improvement. You see, we can actually have two exact rooms with the same brightness, same visible light, but in one room, when I stay in it, I feel more productive, my mood is stable. However, in the other room, I just want to leave, I want to go home. So we can actually consciously and visually judge by our eyes that this room is, okay, brighter than this room, or this room is darker than this room, and I can leave immediately. But when it comes to other measurements that are actually not included, that's why I'm saying there's room for improvement, such as melanopic transmittance, which what Mr. Ben discussed. Guess what? Years later, after staying in the bedroom, using my body as a testing object, I will actually only see the consequences. And what I'm trying to say is that there's not, how do I say this? I'll already be sick by that time. So we do really need to consider other metrics and our testing, and there is room for improvement.
No, that's an interesting topic. I mean, you are born in the UAE, and I think the UAE is a country, including KSA, that is specifically affected by this dark solar control coatings. So it's for your own country to evolve these things. And maybe it's good that we have like international people over here, because we have the expertise from all over the world making things better. So it's a bit of topic. I mean, what we're currently discussing, very interesting, is about what we do currently and what is the future. So maybe Renato, what do you think, what's going to be the future of facades? What do you see the kind of path? Are we going to continue? Is it about evolution or revolution? And maybe then later on, also in terms of architectural design, is there going to be an architectural revolution again, or we just evolve the current approaches? What do you think?
You know that future is difficult to predict. No, I don't know anybody who was able to predict the future. Said that, you introduced the level of light, the amount of VLT, if it should be increased as per the codes. Today there was supposed to attend one of my former colleagues. That I didn't see him. I think he didn't make it. But there's people in the market that they can run interesting simulations, mimicking the reality to assess the level of VLT in different spaces based on the building orientation and the location of the vision areas. So this is one of the areas of improvement, because I'm sure, I don't know how many times you've been in places where you feel that, as Arwa was saying, no, it's too dark and you want to leave, or places that there's too much light and you feel uncomfortable. So this is one of the areas also of improvement where we as consultants, we should be pushing and getting better. There's people that they are already doing really good work on that.
Definitely.
Just maybe to pick a couple of topics. One, you spoke about the evolution of the codes and what's the future. Now, if you see, I myself has witnessed the evolution. If you see in the early 2000s, Dubai municipality used to have just one thermoregulation code. And if I remember, allowed U value was in the range of around 3, and then the U values for the external envelopes were quite high. And over 2 decades, it's substantially changed. Now, the Dubai Building Code, the new one that you have on 2021, which has actually tied it up with the LEED requirements, plus tied it up with the other authority regulations as well. The expected U values of the glass has come down significantly. Then if I remember, the earlier code didn't really speak much about the light transmittance values of the glazing, SHGCs of the glass windows, but the current, so what I can say is it's progressively improving, and also the human-centric requirement is slightly becoming part of the regulation as well. So to me, the evolution of our local building codes, that's in the right direction for sure. And the future, I think, I'll just refer back to a very interesting session that we had on the AI integrated design, which was on the second session, which was a very, very interesting session. And the panelists spoke so much about what's going to be the future of architecture and facade design.
Could I ask you, because we're currently working also on a project in Saudi Arabia, and there we see in terms of architectural design language, a bit of maybe a step back to this more traditional Najdi architecture, traditional blockwork, small punched windows. What do you think about that? I mean, this is the kind of, it is contradicting to modern design, but maybe if the windows get smaller, we can have a higher light transmittance, less dark solar control coatings. Maybe it's a step back, a step to the future. What do you think in terms of architecture?
My view is it's not. It's basically passive solar architecture that's using the building envelope as effectively as possible to filter the light in. So to me, the passive solar architecture is the fundamental approach. I mean, in our practice, we generally tend to say, don't forget the basic building orientation, don't forget where your windows are looking into, see the sun orientation. So don't ever ignore the fundamentals of solar architecture. That's something that you should incorporate. So for me, going back to the references to vernacular architecture or local architecture, which is basically evolved based on the climatic response, I think it's a good step. And there are a lot of principles which we must adapt to our current building design. So I would say that's something we shouldn't forget.
Understood. And maybe just talking about glass, and this is interesting because you said about the solar architecture or the glass architecture. We had projects where you build a building and then shortly after there's a high-rise tower next door. Then glass, as I showed earlier today, glass either reflects the solar energy, it transmits, or it absorbs. And for example, you mentioned back in the days the Burj Khalifa, a very highly reflective solar control coating. So actually the solar energy gets reflected and the adjacent buildings get this reflected solar energy, so the cooling loads go up. So in terms of your glazing, what do you see currently as a trend, also from the architectural point of view, from the energy point of view? Is it more clear glazing, more reflective glazing? I mean, we've seen Saudi Arabia, it's a bit more reflective for privacy, they like high external reflectance. Where do you see currently the trend? What are your sales numbers? Is it more clear, more reflective, more greenish, bluish?
Yeah, no, definitely, it's a good question. Actually, we have seen in the last probably 5-6 years, most of the buildings are designed very neutral. I mean, this is what architects are trying to achieve. That's why even when we develop the latest products are basically very, very neutral. So then the question is, what is neutral? So usually we associate that with a grayish, avoiding any blue, avoiding any green, right? And in this region, I would say the two biggest trends is that neutral or bronze. Bronze is still very, you have been showing Al Tower, which is our DS bronze product, and we were working together on this one, which is also quite well represented in the region. And this is what we see actually not only in the Middle East. I would say even if you look on a global level, neutrality is the trend, clear trend. Light reflectance, unless for some very specific designs or buildings, it's also architects are trying to be modest. And especially when it comes to internal reflection, obviously reflectivity, to make sure that people can enjoy the view, especially in the evening, from inside to outside. And then, well, I would say, there is still, people are mindful, depending on the building orientation and the region where the building is, how much light they really want to get inside. Because, that we are still seeing in this region, majority of the buildings being around 40-ish, which is a big evolution. No? If you're coming from 10 to 40, it's 4 times more light.
Back in the days, the Burj Khalifa, 18%.
18, 17%, and with some, combinations would be even less. But then comes to, and actually Burj Khalifa, it's an interesting example, because at the very beginning, the building was not designed with a low-E coating. So that would not address the problem you are saying, because at the beginning, the initial design was thinking only about direct sun impact. So that's why the solar silver 20 was there to protect during the day. But then comes the, in the evening, everything else around it's radiating the secondary heat, and that heat would go inside the building, which would make AC capex and AC operational cost very high. And Guardian proposed the solution at that time using a low E coating on surface 3 in the inner pane with 1.1 U value, which is quite low for the region. That was absolutely unusual.
But shouldn't we say,
and that's helped.
Even back in the days when the Burj Khalifa was built, and maybe this is also one for the architects, because I think the Burj Khalifa glazing was selected predominantly because of the architectural appearance.
Yes.
Not because of the performance or how much daylight it transmits. So it was maybe not designed for the human beings, more for the external appearance. So shouldn't we rethink our architecture? I mean, are we still building buildings or designing buildings for us as a human being? Yeah. Or for the profitability, for the external appearance? And maybe Ara, for you, I mean, now the building codes are, as I use the building codes are minimum requirement. Do you think we should make them stricter, or for you as a sustainability consultant, is it sometimes a bit of a shame? Because we still see product being very commercially driven. So we only achieve the minimum requirements, but nowadays we can do so much better if we spend a bit more money. So how do you actually then kind of discuss with clients to advise the clients? Because I think ideally want to push them a bit further. What do you think?
Well, from the very beginning, buildings were built for occupants. And solar, those technologies that will help improve our human well-being, they are considered innovations. And any innovation, when first introduced to the industry, for sure it's going to be costly, but it won't necessarily be expensive. I mean, if we take low E coatings as an example, 30 years ago till now, the reduction in low E coatings around roughly, I would say, 75%, which is significant. Thanks to what? Thanks to mass production, thanks to competitors, because of enough awareness raised, and thanks to the scale going up. And because the scales went up, the cost for sure go down. So why won't the same story be repeated again, especially when there is enough evidence on the impact and the importance of such technologies? I actually see that there is a potential for introducing those innovations to the industry.
Yeah. Renato, you're working as a product manager, so you're currently in between clients, consultants, architects. Would you sometimes want to push them or do something different, or what's your take? I mean, sometimes we see this project and think, oh, just do this, but the client, what do you think?
Clients, they expect that they employ a team of engineers, whether they are from the same company, that initially should be more easy, that they work all together, and consider all of those parameters and come up with a holistic solution that can fit most of these requirements. So it's about collaboration, spending time, investing time, and come up with alternatives. So.
But it's sometimes tricky. I mean, I'm working as a consultant. We see initial designs where, especially in the Middle East, predominantly the wow effect. And then there's a certain architecture and function pushed into this one. And this may be sometimes where I think I was mentioning the Gadea or the Saudi Arabian projects, they go back to a kind of more human scale. And a lot of people tend to like this old architecture. I think in Doha they did this, at the creek here in Dubai, mimicking old architecture, and people walk through the streets in the afternoon, the night, have dinner next to old Najdi walls, old timber lintels, and it's very interesting. So maybe the sustainability of the future might be a mix between old things and new things. I've been doing presentations over the last years, and I was looking also at old houses and how efficient the old architecture in the Middle East was, with, for example, with the wind towers, with a courtyard to collect wind, and the wind was going through the courtyard to the wind tower and up. So having natural ventilation, having these mashrabiyah windows where you have privacy, but at the same time you can have wind and airflow through the windows or through this kind of mashrabiyah screens. So even in the past, people have been very smart. And also in the past, it's very interesting that nowadays we have actually air conditioning over here, which is maybe the worst thing in terms of sustainable building design, because this consumes the vast majority of the AC and the electricity. And back in the days, people lived without air conditioning. So how did it work? Is it just a thing of modern society that we switch the AC control down? Can we go back? So it's a lot of things to discuss, and maybe do we need to start with a human being? Do we need to say we don't need to live in 22 degrees Celsius, push it up to 25? So interesting things. So do we see clients implementing that, or is it still, because it's a bit of an American European design that came to the Middle East. But do you think there might be some evolvement in terms of rethinking?
Yeah, my view is there is definitely push towards human-centric design, whether it's developers. To some extent, it's being marketed as human-centric projects. So both developers, the builders, I think and the institutional developers as well are pushing more towards a human-centric architecture, which is creating spaces more conducive to better well-being of the occupants. So I think that's coming more and more to the center of the design.
Interesting, interesting. So the future about glazing. So Jasmine, what's in your cooking recipe book for the next 10 years? Is it, because I think some of your coatings are technically amazing, but I think in the future we might question, is a complete blocking of infrared, was it a good thing? We don't know yet to full extent. For the UV light, for example, we sometimes even nowadays consult architects and clients for laminated safety glass, please use a UV transmitting PVB interlayer. The products are out there, which were invented for greenhouses, because we figured out that plants are not growing without UV light. So there was a special PVB interlayer developed for greenhouses. Now it's a question why we as a human being are not getting this UV transmitting interlayer. So a lot of things that maybe only time shows that we didn't understand this thing fully in the beginning. This is when we say maybe we push technology to very high. You are now producing triple silver low E-coating with a selectivity that's amazing. So you only transmit the visible light, which is amazing for the sustainable building design. But maybe we need to question, is it good also for the human being? It's not only the glass suppliers questions, also the legislation. I'm presenting also at international facade and conferences. I'm discussing with the code committees that we might need to rethink the code requirements. But it sometimes takes time because it's this thing between psychology, medical studies. So it's not that we as a facade alone can decide that. It needs to be backed by evidence. So maybe in the future also your coatings need to evolve. And I think guarding glass is one of the major big players. You're the ones who can push things ahead. What do you think?
Yeah, definitely. I think, you mentioned that there is some studies ongoing, right? We still don't know exactly what is the effect. And coming just very quickly back onto the building codes, they are very limited, right? We are looking at 2-3 parameters. So as far as the other criteria, it's not being part of a building code. It's always going to be very difficult to push unless, a unique project here and there. And to compensate lack of those, that's why we have LEED, BREEAM, to make it better. So, but coming back to the coatings, I think there are a few things which are not new, but which today are not, let's say, scalable solutions. We can talk about VIG, right? Vacuum insulated units, right? So Gadea has a solution with that. But we know today it's either too expensive or limited. We can talk about dynamic glazing. I think this is the one as an idea, right? And there are different ways of, making that facade or glass dynamic. Okay, but today again, either to your point, it doesn't enter into the budget, or it is limited with the sizes. But like anything else, it's going to evolve over time. So what we are trying to do is to constantly interact with you, with the clients, and to make sure that we know what we need to bring to the table, and that's the goal. I think we need to work together in order to bring that better product tomorrow for people, right?
Definitely, fantastic.
So,
I think we're coming to the end of our panel discussion. I would like to ask all of us to have a quick closing statement. So maybe Renato, Jasmine, we go around. So what do you think as a kind of closing comment, just recapturing this discussion, your thoughts? about the future, about this topic?
Keep working on it. So now you are, through this panel, we are creating awareness, and maybe some of the people here will think about it, will consider it, will investigate further, will get involved, and we influence it. So, because it's a long process.
Definitely.
So for me, facade, it's a big passion in general, not just glass. So definitely, in a way, on one side, it is a barrier between us humans who are mainly inside and the external environment. And we want to interact more and more in a healthy way. So let's work together to bring those products that will make that facade actually part of our skin. And allow us as human beings to enjoy even interiors.
Fantastic.
Yeah, I think it's a very, very good point, Yasmin. I think the design aspiration and the product development, they should go hand in hand to achieve what we really need to. So, I mean, as much as you AI technology in design, I think the same tools are available for the manufacturing side as well. I would say the product development and the design should go hand in hand. That's my view.
Awa, your closing remarks.
What I would say is that we eventually evolved under the sun, and maybe we don't need really to block that much of the sun. We can actually shake hands with the daylight and figure out future opportunities.
Fantastic, I totally agree. So my closing remarks. So first of all, thanks to all of you for this panel discussion. My closing remarks is send your kids outside, send your children out into the daylight. We're spending 87% of our time indoor, with children even more. Children use too much of electronics. The human eye, the transmittance in the blue light spectrum of a kid's eye is higher than with adults because it is aging. So they're even more affected by electronics and the blue light emitted by electronics. So this is maybe why your kids are not falling asleep. So send your kids outside, stay health and safety, and thanks to everybody. Thank you.
Thank you.
Thank you.
Thank you.